Good morning, everybody, and welcome to the second day of the Irish District Energy Association's National Conference. We welcome you all today. We're delighted to see the interest in the District Energy Conference this year. So we just want to first acknowledge and thank all of the speakers today for to prepare their presentations and to be with us. And also a big thank you to our sponsors, Vattenfall and Dublin Waste to Energy. So just to let everybody know before we kick off that this session is being recorded and that the recording will be circulated in a day or two after the conference is finished. And if you are using social media, could you please use the hashtag? The hashtag for the event is hashtag District Energy 20, so capital D, capital E. And you can follow us, you can follow IrDEA on Twitter as well to catch up on some of the tweets on the event. So we do have a Q&A function, which will, a question and answer session will take place after each of the sessions, session 1 and session 2 today. So if we could ask the attendees to please use the questions and answers box. So there are two boxes. One is for chat, is a chat box. The other is a Q&A box. So you could please use the Q&A box for any of your questions, and we'll try to get through as many of the questions as we can. There are a lot of attendees due to join us today, so we'll get through as many as possible. Yes, just a quick introduction then for those of you who are joining today who maybe couldn't join yesterday. So IrDEA are the Irish District Energy Association. We were set up back in 2018, and this is our second annual conference. We've a growing membership, which represents different sectors from academia, private sector, public sector, consultancy, technology suppliers, right down to community cooperatives. And we have a good mix of our membership and speaking today with us as well, and bringing their experience to the conference. And I suppose while it's a shame to not see you all face to face, as one of the advantages of having an online conference is that we can have more international speakers, and we're delighted to have the kind of range of speakers from other countries being able to easily join us online. And you know, you can stay in your slippers and enjoy the conference, which is also a bonus. Without further ado, I'll just show you first the lineup for the day, an overview for the day. So today's sessions, the first session is called Past, Present and Future, the Experience of District Heating in Ireland. And this is where we'll have a look at some of the projects that are ongoing in Dublin, which will be presented by CODEMA, Dublin's energy agency, and also the experiences of some of the communal schemes and campus schemes that are already up and running in Dublin. And there's a lot of experience in Ireland in those kind of schemes and how to operate those and the customer experience. So it's great to get that insight into how things are actually working on the ground in Ireland at the moment. And then the second session is international policy and regulatory review. So what can Ireland learn? This is particularly important for us coming up to, there's a new policy framework being developed in Ireland now, and it's good to see, I suppose, what we can learn from other countries and who, I suppose, are in similar positions to us in terms of their growth of district heating. So the first session then, I'd like to introduce our first speaker, which is John O'Shea from CODEMA. And John is an expert in district heating and cooling networks, having worked in the areas of heat planning, policy development, detailed design and project delivery of such systems across Europe and the Middle East over the last decade. But since joining CODEMA in 2018, John has worked extensively on new large-scale district heating projects in Dublin, as a technical advisor supporting the local councils in design, evaluation, stakeholder engagement, procurement, contract development and strategic development. So a busy man. And John is going to give us an overview of the projects in Dublin at the moment. So I'll hand over to you, John.
Great, thanks, Dana. Just share my screen. Hopefully you can see my slides there. Yeah, so yeah, as Donna was saying there, my name's John O'Shea, and delighted to be speaking here today and give an update on the projects that we're working on in Dublin in this kind of Charles Dickens inspired session on district heating, past, present, and future. So I'm the energy systems analyst with CODEMA, which is Dublin's energy agency, and I suppose this morning I'm going to be the ghost of district heating present. So just to give a bit of background on CODEMA then. So you can see we're a relatively small team there. That's a pre-COVID picture, just in case anyone's scandalized by the lack of social distancing. And you know we're Dublin's energy agency. We're a non-for-profit public good company, limited by guarantee, and we work on behalf of the 4 Dublin local authorities to accelerate Dublin's low carbon transition. And we do that through sort of innovative local level, energy and climate change research, planning, and project delivery. You know, with the ultimate goal of mitigating the effects of climate change and improve the lives of citizens within the city. And I won't go into too much detail here, but just to say CODEMA support the local authorities in the development of district heating projects, and everything from kind of planning, so like heat planning, all the way through to project delivery and pipes in the ground. And also we work internationally, I suppose, through a lot of European projects to kind of share our experience with other cities around Europe as well. So the first project I'm going to talk about then is the Tallaght District Heating Scheme, which is utilising the waste heat from a data centre down in Tallaght. And I suppose how this kind of scheme came about is, you know, a little bit of background. I suppose the kind of growth of data centres in Ireland is kind of well documented at this stage. And I suppose there are certain issues, I suppose, with that, but also opportunities that they present. So as we can see, you know, from IrGrid, they expect that 29% of all electricity demand will be going to data centres by 2028. You know, and there's 9 billion investment in grid and generation to support that. And you know, there's obviously a knock-on in terms of CO2 increase due to that electricity demand. So the question arises then, I suppose, you know, how can we reduce the CO2 impact of data centres? And I suppose kind of politically, it's probably data centres can be a slightly contentious issue as well. You know, they use a lot of energy, probably don't produce as much jobs as you'd expect. You know, they do support a lot of PPAs, which is great, but you know, I suppose the kind of on the district heating side, then district heating kind of provides another opportunity for a more tangible local benefit, I suppose, rather than kind of numbers on a spreadsheet that PPAs provide. So the kind of general design concept then for the Tallaght scheme is, you know, we're taking the waste heat from the data center, we're passing it through these large scale heat pumps to kind of upgrade the temperature to a usable level. And then, you know, we're looking at thermal storage then to kind of balance out the peaks and troughs of demand, and also help balance the electrical grid. So it's a very cost effective method of storing energy. And then we've got our backup system there as well, our large scale peaking boilers that, you know, in times when the heat pumps might need maintenance, etc. Yeah, so just a bit more detail on the heat pumps then. So they're 2-stage heat pumps. So they're essentially, I suppose, 2 stages. So there's 2 compression cycles. So it's kind of 2 heat pumps bolted together, which kind of allow us to maintain really high efficiency, but also deliver high temperatures. So that's important when you've got older buildings connecting to the network, which don't have fabric upgrades. So we can still supply at the temperatures you would expect from a boiler, for example, without the need to retrofit those buildings. And as you can see down the bottom, it's sort of in a modular kind of design where we've got essentially 6 modules. So I suppose 3 2-stage heat pumps connected there. And then to the system itself, then I suppose the kind of benefits we see from operating the system, so saving 1,400 tons of CO2 per year based on just the connected in phase one. And then we've got 100% reduction in fossil fuel use, so it's a fully electric system. The backup boilers are also electric in this case. So there's cleaner air, our local air is much cleaner with no particulates to be floating around in the air down in Tala. And also I suppose utilizing this off-peak electricity. So with storage, and we've looked at a few different types of storage, including the possibility of using the buildings themselves as storage. And then also utilizing the waste heat from the data center, which currently has no value. And providing this kind of high efficiency, because we're as well as providing heat to the network, we're also providing cooling to the data center as a byproduct. And I suppose it's kind of a more integrated energy system, which is very much the drive from Europe at the moment to look at the kind of more holistic picture when it comes to energy systems. So this is one example of where you kind of have that nexus between the electrical grid and heating grid. So that allows us to kind of provide grid balancing to the electrical grid, and also incorporate greater portions of renewable electricity during low demand times. So when wind turbines would typically be curtailed, we have this kind of demand to switch on to utilize that electricity. And just to provide a bit of a progress update then, so the red line, I suppose, kind of shows where we are in proceedings. And currently, so we've set up the South Dublin District Heating Company. So funding has been secured through various means. So the Climate Action Fund has provided 4.5 million for this project. We've also got some money from IrDEA, so the HeatNet Northwest Europe project, for which Codima were the lead partner. So this was one of the pilot projects under that project. And then also the council themselves putting in money, and the ESCO, who are going to be doing the design, build, operate, maintain of the project. So the contract for that has been signed between the council and the ESCO. And I suppose in terms of delivering the project itself, so the kind of long lead-in items have been ordered. We're finalizing the detailed design for the energy center, and site surveying is getting underway. And then kind of construction will be starting in earnest then in the first quarter of next year, and then with heat on coming in quarter one of the following year. So it's slightly over a year, I think, still there. So yeah, I guess we've kind of looked at Tala, but I suppose we're already starting to look further afield at other opportunities in South Dublin and elsewhere in the county. But I just have this map here as an example. So you can see in South Dublin, we've kind of identified 9 opportunity areas in total, one being Tala itself. And we've had some early engagement with interested key stakeholders in a number of these sites. The second project I suppose I'll talk about is the Dublin District Heating Scheme, which is utilising the waste heat from the Dublin Waste Energy plant down in Poolbeg. And the kind of design concept there is, the waste is burned in the waste energy plant, which generates electricity, but then we will take the heat from that process to heat homes in kind of Poolbeg and city centre area down by the Docklands. So there's enough waste heat there to heat about 50,000 homes, like the equivalent of 50,000 homes. And currently, I suppose it's that heat is being sent into the Dublin Bay, so it's heating the fish rather than heating those homes at the moment. So I suppose just to give a bit of background, generally what we're going to do is take the I suppose the steam turbine here. So on the low pressure side, it needs to condense the steam to shrink it to spin the turbine. So that's currently done by water from the bay, but we're hoping to connect in our district heating pipe there. And provide that kind of element to the waste energy plant. And then just to kind of show where everything's kind of laid out. So we've got the waste energy plant there in the kind of bottom right there. and then, connecting into the Poolbeg West Strategic Development Zone, and then on into the city centre and the Docklands area. Just to provide kind of a progress update then. So I suppose the council have gone out with some soft market testing on the kind of commercial and business model options that are open to them, and they've got feedback on that, and that's been completed. Also appointed a technical advisor for the project, and they've been looking at things like heat production analysis and the various options around how that heat can be produced, and specifically around backup or decentralized redundancy in the city. And then also the climate action funding has been secured. So CRDEA were responsible for that application and supported the local authority on that. And then also these kind of working group teams have been set up and are now up and running in the kind of three main areas of kind of overall management and coordination of the project, and then specifically on the technical aspects and the legal aspects. And there's been an awful lot of work done on the stakeholder engagement side as well, where the council have been engaging with buildings down in the Docklands area to find out a bit more information in terms of their heat demand profile and kind of timescales in terms of when they might be replacing certain elements of plant in their buildings. And also I guess detail on what's already existing and installed in the buildings, whether they're electrically heated or whether they have a wet heating system. And all this kind of information is kind of fed back into the financial model that's being worked on as well. So yeah, I guess kind of looking at a slightly broader picture then, I suppose we at CRDEA have kind of been looking at updating our heat source map, and this is kind of an ongoing process as part of the regional energy master plan that we're working on, and also the work we're doing with the councils in developing their county development plans. And I suppose the kind of one extra heat source, I suppose, that's been added since this is the seawater heat source. And that's kind of bumped up the figures slightly. So we have a slightly revised figures in terms of overall heat potential in the city. So it's up to 3.5 gigawatts now, which is enough to heat approximately 1.6 million homes. And I suppose it shows here where we've kind of started with the South Dublin project and the Poolbeg project. But I suppose the next question is, where do we go next? So we've kind of been getting a lot of engagement from developers who kind of see district heating as a very cost-effective way to meet their Part L requirements. So they're kind of looking in more detail at kind of communal and district heating schemes. And then we've kind of been in kind of early engagement on an industrial-led scheme to the west of the city out in Grange Castle. And then we're also looking at potential sites for a district heating project. So we've been working with Geological Survey Ireland to kind of identify potential sites for a project in the geothermal area. And then just I suppose another kind of project that we're working on as well, which isn't kind of a pipes in the ground project, but it's the Decarb City Pipes 2050 project. So there's a kind of a capacity building and transition delivery project. So we're working with city partners from Bilbao, Bratislava, Munich, Rotterdam, Vienna, and Winterthur in Switzerland. And I suppose we're kind of looking to develop effective local governance structures to kind of deliver a kind of a decarbonized heating sector in these cities, and then kind of basically look to identify and address knowledge gaps within the cities through kind of peer-to-peer learning, and identifying helpful tools, policy mechanisms that are used in different regions in Europe, and then also I guess educating people in the area of change management, because there is going to be obviously a large element of change and how people have done now. So that's kind of a key aspect as well. And I suppose that from CRDEA's perspective, then we're kind of responsible for the work package delivering the transition roadmaps. So kind of overseeing the production of these kind of actionable transition roadmaps within each of the partner cities. And I suppose one of the other kind of interesting points in this project as well is the involvement of a distinguished advisory board. So We've got a lot of kind of experts from around Europe, some of whom work in kind of the gas and utilities area. So we've got people from Eurogas, who are the kind of lobby group for gas utilities in Europe. And I'm sure like it'll be great to have them on board and, you know, challenging any of our conclusions and results and getting some really good input, you know, in areas like green gas and how that might fit in to the broader energy system as well. So some of the kind of key outputs from that project as well are to kind of enhance skills of more than 200 public officers. So basically upskilling people within councils and you know, within the cities themselves, improving, you know, more than 50 policies and strategies. And then, of course, motivating other cities, so more than 80 cities to start this road mapping process themselves. So trying to take what we've learned in the project and spread it across Europe. Yeah, so that's it from me, really, I guess. Yeah, so thanks for listening, and yeah, I'm sure there'll be questions in the Q&A, but my details are there anyway. If there's any further, or you know, if there's any complaints, you can get in touch with me there. So yeah, thanks very much.
Thanks for that, John. Great overview of what's happening in Dublin, and I know one of the local authorities there, Dublin City Council, is also a member of IrDEA, and we know that they're doing a lot of great work, the team there, to progress the project in the Docklands area. So next up then we have Paul Noonan, who is the BMS manager for UCD Estate Services. Paul Noonan is the BMS manager at UCD, and he specialises in the sustainable delivery and operation of building services at UCD, including the site's district heating, which I think has been around for a long time. They're probably one of the oldest district heating campus systems in Ireland. He also does ventilation and CHP plant. And Paul has been central to the implementation of ISO 50001 at UCD and delivery of over 60 energy efficiency projects, which are contributing to UCD's impressive energy performance. So Paul, I'll pass the floor over to you.
Okay, thanks very much. Thanks, Donna. Thanks, John. That was a great, good presentation there. So I just share my screen here. So just briefly, we're just going to talk quite quickly about just energy and district heating in general at UCD. We've had our system from about 1960. So, you know, we've learned a good few lessons about it over time. And then what are our sort of plans for moving forward? Obviously, we're looking at going towards decarbonisation and just a bit on the lessons learned. So, in terms of just energy at UCD, UCD has had a long history of energy management. We've had a dedicated energy unit since about 2002. So we've always taken energy very seriously. We were certified to ISO 50001 in 2016. So that's helped us kind of put in a system, an energy system, how we go about energy in our day-to-day lives and everything we do from procurement to design. So, you know, that's really, it kind of helps keep energy and sustainability to the forefront. We also work very closely with the Sustainable Energy Authority of Ireland. So they've been great in terms of, you know, giving us supports and the various different tools like gap to target tools and things, and partnership that kind of helps us with doing feasibilities and things like that. And then all the universities in Ireland, it started with the main Dublin universities, the E3, but we also have another energy group now, U9, where we kind of share ideas, you know, because we're all doing kind of large scale projects, have similar kind of issues, typical same characteristics, same kind of opening hours and research levels, that kind of thing. So it's great to share ideas. And then we've had our 2020 public sector targets, UCD's public sector, and we actually reached our energy efficiency targets in 2019. So we actually got a 35%, a bit higher improvement in energy efficiency since the baseline. So just for those who aren't in Ireland, UCD, it's Ireland's largest university. We're about 5 kilometres south of Dublin City. And on a non-COVID day, on a, like say last year, we'd have maybe 30 to 35,000 people on site every day. So between staff, students, visitors, just people even going for a walk. We've quite a big site here with lots of natural walks and things like that. So the district heating history, it started as a peat-fired system in roughly the 1960s. And the pipework is a 12-inch flow and return pipework. And maybe unusually enough compared to district heating schemes today, there's a walk-through tunnel and associated subways into buildings. I'll show you a bit more on later slides. But the fuel source then for the system has kind of naturally migrated from peat, there would have been trucks arriving every day, to heavy fuel oil, to gas, and then gas led to CHP and biomass. So, a good bit of change there. And obviously we're looking out for what's coming next. The system operation changed from steam-based to low-temperature hot water. And in the 90s, we sort of dipped our toe in terms of CHP. And we're now on our second generation of CHP, which would be obviously more efficient than the earlier generation. So that's a sort of, the picture on the right is our main walking duct, it's the spine of our district heating system. And it's about 1.3 kilometers long. And the graphic on the left just kind of shows the way the energy center, the district heating energy center, we have biomass, gas boilers, they inject heat into here. And these are buildings which are connected up and down along this walking duct. And I know it's from times gone by, but this walking duct is such a great asset. It's great to have it, to be able to, for maintenance, even running cables or putting in controls, getting from one building to another. So, really great asset. I know on the most recent buildings that would have been brought online, we don't have the walking duct, but it was great foresight at the time. And those pipes there are the district heating pipes, 12-inch pipes side by side there. So just geographically, that's sort of what it looks like. Our energy center to the left of the picture, it's up near, if anyone knows UCD, it's near the water tower. And then we have the duct runs more or less down through the center of the campus, and and with subways into the plant room in most buildings. So that's great in terms of access and maintainability. So more to the right of the building, of the picture, we have one or two new buildings which would be used direct buried pipework connecting to the heating system. So just some of the hydraulic development.
Paul, we've just lost sound on your mic.
Is that okay?
Yeah, you're back there.
Yeah, sorry, yeah. So we've generally moved towards hydraulic decoupling of all buildings. Initially that wasn't always the case, but you see on the picture to the left, that's a typical subway, which would bring the district heating pipes from the main spine into say a building plant room. And then to the right, the picture to the right would sort of be what you'd be presented with in a plant room. So we've a plate heat exchanger in some buildings. So that's looking at that now. That's a space heating plate heat exchanger. We could have a hot water heat exchanger as well, depending on the building operation. And typically then beside that, we'd have a large two-port control valve. So that's allowed us then to facilitate dynamic pump control. So, we can control the flow into that heat exchanger, to control the secondary temperatures. So and that's something that we're always looking at, monitoring flow rate optimization, the flow rate. So typical flow rate on a day like today would be maybe from 100 to 120 liters a second. So just a nice graphic. I should have told you there's this is I'm an engineer, so it's a few technical detail in here and operational detail. But so you can sort of see a cross section of the equipment that we have. That boiler on the left is it's gas fired, but that would have been on heavy fuel oil and peat back in the day. Our energy center, where the top 3 boilers are, is below ground. So back in the day, trucks would have driven up on a ramp, and if you were able to see the roof there, you can see the kind of the hoppers where turf or peat would have been loaded in, poured down into the burners. There we have a 950 kilowatt biomass boiler. It's wood pellet, and then 2 gas boilers to the right there. And then on the lower picture there it's their second generation of CHP, which are containered units, high efficiency, obviously very reliable, and so they've been a great asset to us. So there's 2 engines there. These are the sort of plant sizes, but there's a 1.2 and a 0.8 megawatt CHP. And that just gives us kind of idea of the plant that we have. That older boiler that we saw earlier to the left is more or less, it's a backup peak boiler now. Really, unless it was really snowy outside, we wouldn't necessarily fire it up. So, just there, I need to move this. Future low carbon developments, then really for us, an area of great interest to us would be high temperature heat pumps, and also exploring deep geothermal as well. We are not too far from a fault line, so that's just something that's kind of going on in the background. Sorry, Mike. So just this, something happened there with my slides. The system characteristics there. Well-insulated pipeworks. Pipework you may have seen from the picture, like they're doubly insulated pipeworks. We've improved that over time. We've added more insulated fittings, insulation bags to fittings and valves, that kind of thing. We've fairly good, well, I'd say very good BMS controls. BMS would be a strong point here in the college. We have a dedicated single site system with a lot of controllers. Access to everything is good through the walking duct. Buildings again can be brought on and offline automatically. So some of our buildings would also have either mini districts inside them with maybe gas boilers or local CHP. So at different times of the year, we can bring them online, bring them offline. In the summer, we can decide what's the best thing to do here. What's the most, say, from a primary energy point of view, what makes most sense to be connected to the district or to use a local plant. The system is currently connected to about 120,000 meters squared of building. Again, a variety of thermal loads between space heating. We a lot of laboratories, and laboratories then would bring about kind of 24/7 ventilation requirements. So we need to make up for heating to allow for that. Obviously, there would be heat recovery in the building, but still you would need some heat. Water heating, and then say just a typical year delivery of say 9 gigawatt hours of heat, and most recently 65% would be from CHP and 35% from boilers. So our future plans, really we're talking about decarbonizing heat. We really see we've had our 2020 public sector target in terms of energy efficiency, but now we have a critical carbon reduction target, coming to us now. So really, we see that decarbonizing thermal heat is probably our best way to move forward. And really, our district heating is an enabler for that. It's going to enable us to do it. Because if you think about it, we've got old buildings connected to our district heating. We need to sort of bring those up to a BERB level. So by us decarbonising our energy centre, our thermal heating, you know, that is going to help the performance of those buildings and our overall carbon performance. So, you know, that's just the note there on leveraging. Continuous improvements to increase efficiency. So lower temperature design, you know, for all new buildings. Obviously, we're looking now at NZ buildings for new buildings, but we're really trying to operate them at a lower temperature. So we've always been thinking about, obviously, standing losses and trying to avoid thermal dumping. So say we're used to CHPs. So our key thing there is trying to stop the CHPs from dumping heat. So now we're still thinking about that. We're also now thinking about COPs and seasonal COPs of future heat pumps. How can we operate the buildings at lower temperatures? So we're looking at decoupling domestic hot water, you know, with local top up. So, you know, you take as much as you can from the district heating while operating the district heating at a lower temperature, and doing a smart top up with, you know, potentially another heat pump, or, you know, other ways of doing that. Larger heat exchangers and heat emitters. Improving heat metering on some of our older, an area that we want to look at, and then just widening the overall delta T. Lower average temperatures in the system, that's going to be lower district heating losses. You know, so that's, you know, that's good, and as well as the pumping benefits from that. That walk-in duct that you walk through, anyone we've ever brought in there before, any visitors have always commented that it's a lot cooler than we would have expected, given that, you know, we're moving so much heat through the tunnel. So, you know, it's kind of, you know, it just shows that, like, thinking ahead, and it was doubly insulated at the time, you know, it pays off. So some lessons learned, again, I'm getting technical, but using good quality package heat meters, or the heat integrators, we think is a very important thing. Very hard to put them in after the event, especially when they're live buildings. So really, we think, you know, in our guidelines to consultants and that, you know, really ultrasonic heat flow devices, good quality meters, putting in sufficient temperature and pressure. So really, you know, I know it's different, say, than this being a residential development, but say for on large commercial buildings, putting in DP sensors at all the heat exchangers, temperature, flow and return temperatures on primary and secondary side. Then when you do put in those temperatures, pressure sensors, have isolation valves, because you don't want one to fail and then wait till the end of the heating season to fix it, you know. So just allowing things like that in the initial design. Watching for flow to return bypasses. This is a real bugbear of mine in particular, you know, that really you put in something to allow you to commission the system at the start, make it easy to commission on day one, but potentially something going wrong there it poses a risk to mixing and to the operation of the system for the next 20 or 30 years. So really, we like to have really good justification for putting in bypasses or anything that could go wrong and drag down your system, you know. So it could be putting in 2 valves instead of 1 and hoping that they both stay working. So using all available data. So obviously we have 2-port valves on our buildings, large 2-port valves, but those 2-port valves, just because you tell them to go to 50% doesn't mean that they will go to 50%, or just because you tell them to close doesn't mean that they will close. So all those valves have a feedback signal, a positional feedback signal, which aren't always connected. So the information is kind of sitting there waiting to be used. So we sort of say, well, wire that in as well. So then we know when you tell a valve to go to 10%, it actually does go to 10%. Or if you're looking at it, you can see, oh, there's a valve passing here, or the valve isn't closing when it should be closed. So these are all sort of little things. Heat meters as well, they have generally have a flow meter out, a flow rate output as well, which isn't always tapped into. So it can be an analog pulse or whatever. But by using that data, you can build up a great system graphic. And I think by having a good system graphic, you can see what's going on in your system. You know where the heat is going or where the flow is going. Is it going where you want it? And then monthly generation reports. So we look at kind of EPIs on a monthly basis. You know, how much CHP heat went in, how efficient were CHPs, how much boiler heat went in, what's the pumping performance. So just that on a monthly basis, it kind of ties in well with our ISO 50001 system. And, you know, it gives you, just make sure that if there's any drop in performance, it gets spotted. And then just a building by building approach to balancing. This is really going to be key for us moving forward, is that the delta T on the system, especially now with heat pumps, you know, and trying to say, take a balance from the secondary side of a building up to our heat exchanger, and just, you know, a bottom up approach, building by building, start at the biggest building, work your way up on a continuous cycle. Maybe every couple of years you start looking at them as well, because people go in, they modify things, they're, you know, responding to complaints or issues, and, you know, before you know, commissioning valves have been opened, adjusted, etc., etc. And then overall, the low temperature design is key. And considering energy efficiency design, so challenging all new designs in terms of trying to, you know, make sure it's, you know, it's really been considered from a you know, optimizing and sustainability and life cycle costing for carbon. So that's really it. They're my contact details.
That's brilliant, Paul. Thanks so much for that. Very interesting to hear about a scheme that's been in place since the 1960s in Ireland. And I suppose it's a great lessons to be learned there from a campus system for future campus systems like the one in Grange Gorman, the TUD campus there, and the new system that's going in to connect the Tallaght scheme as well in the TUD Tallaght campus. So thanks very much, Paul. And if you've got any questions for Paul, don't forget to put them in the Q&A box, and we'll come to that at the end of this session. But next up, we have another IrDEA member, Kaizen Energy, and Fintan Lyons is the founding and managing director there. Kaizen specialise in the operation and management and maintenance of communal heating networks. And Kaizen currently operate over 50 local networks across Ireland, which supply direct heat and hot water to over 6,000 residential and commercial customers. So Fintan, I'll pass over to you.
Thanks, Donna. Good morning, everybody. Thanks, Donna. So, Fintan Lyons from Kaizen Energy. As Donna has suggested, we are heat network operators, and I suppose most of these systems that we would operate, you would probably more classify as a local heat network or a communal heating system. So we're talking individual developments at the minute, until such time that that the larger networks come along and we can actually join these up. So we would generally see ourselves as the ESCO, or a role referred to as the energy supply company. We would take management and operational responsibility for the infrastructure for those local networks. Those systems, we found it's quite important that they belong to the various management companies that are made up of the residents that are living there. Again, these systems are predominantly residential. We do have some mixed use, but generally they're mainly residential. So we would, so I suppose you'll see there on the picture on your right hand side, that's just I suppose a Google map of Dublin city centre, and you can see there's various different developments. At the minute, we've just over 50 of these individual developments, not only in Dublin, but across Ireland, but generally mainly in Dublin, and just over 6,000 heat customers. So that's heat and hot water that we would be supplying to them. What we would do is, generally speaking, anything related to these systems, you put them under an umbrella, and we take responsibility for them. So on the softer side, that's everything from the procurement of the fuel in, which is generally speaking gas, plus a small bit of biomass. we would then do the budgeting, the heat budgeting, the striking of those heat rates through to the issuing of the heat bills or the recovery of those heat charges, maybe through prepay systems. On the harder side of it, then we have, I suppose, full responsibility in regards to the operational, the strategy of operating those systems, making sure they're efficient, management of the efficiencies, obviously, down to plant maintenance and both corrective and preventative maintenance. I suppose we're in business now just over 8 years. We've seen a lot of do's and don'ts regarding these systems, and we tend to try and give our experience across to developers, consultants, contractors, to everybody involved in the life cycle of these systems for new builds. So I suppose I was asked to give I suppose a little bit of an oversight that if I was a heat customer in Ireland, what would my perception of a heat network be? And I suppose initially I'm going to start off on a bit of a negative front. And just to give a couple of examples as to why and what I suppose the factors that were contributing towards these points were, I suppose if you take a view back from a lot of building stock that may have been put in regards or built in regards to early mid 2000s, I suppose the heat customer was in fact picking up the tab for the operational cost of running the system, and unfortunately there was a perception that those costs were quite high, and they were quite high, and they were high for a number of reasons, which I'll go through in a bit more detail. But there was also simple things in regards to plant reliability wouldn't have been as good as it is now these days, so you would have had system outages wouldn't have been overly unusual. A big problem with regards to overheating in buildings, again down to poor choices during design and installation, which I'll go through again. I suppose there was a lack of available knowledge to both customers and residential owners and management companies that this was a relatively new area for them. So there was a bit of frustration there in regards to, I suppose, a lot of the information that was maybe available was I suppose was experience that was outside of Ireland, and sometimes that wasn't it wasn't very relevant. I suppose you had a lack of available operators. We're probably still seeing this sector is still quite small in Ireland, and we're probably still seen as quite specialised operators of these systems. And there was quite a few companies that I suppose over the years that dipped their toes in it that may not have, I suppose, had the experience that would warrant, that was required, I suppose, for these systems. That led to a bit of frustration. And I suppose one of the things that what that also led to is that you had various different approaches to how an ESCO would manage these systems, and it was often perceived as a monopoly of supply, and in some cases rightly so. You had some ESCOs building in significant profit margins on say the supply of gas, or there would be built-in profits in regards to the sale of the heat to the tenants. And one of the ones that hasn't really, I suppose, moved on, and we're keen to try and do this, is that it's not and still is not a regulated utility. So this heat is not a utility in Ireland at the minute. It's not a recognised utility like you might say gas or electricity at the minute. So I suppose just some of the factors that led to this, and I think it's not a surprise that per system design, again, that was due to lack of knowledge, lack of experience from everybody relating to the full life cycles of these systems, but predominantly down to initial designs. We have systems that are far oversized. They're huge capacities and large header pipeworks, large distribution networks, poorly insulated distribution networks, which leads to high heat losses and again just high cost. Poor equipment selection, it's something that can be seen as relatively quite straightforward, but we had a lot of buildings that were, I suppose, they were either put in and I suppose cost was the biggest factor in trying to do them as cheaply as possible, which is not always the best way of doing things, or in fact you had the opposite side of the scale, where some of these systems were overcomplicated. You had bespoke metering systems bespoke heat stations that you might have had suppliers maybe that had gone out of business and they weren't able to stand over them anymore. And I suppose longevity is a big plus for these systems if they're done right. And in recent years, a couple of these systems, or a number of these systems, have had to be effectively retrofitted to remove that bespoke equipment. So that's led to obviously frustrations with the heat customers and the management companies that we're dealing with. Per procurement practice, which is something again which is very obvious, but if you go back maybe 10, 15 years ago, procurement was around energy was almost seen as a bit of a specialized area in itself as well. And I suppose it was very easy, given the various different, I suppose, approaches and ESCOs that might have been involved in it at the time for per procurement. It was just simply you would let your procurement slip. You're talking about higher input rates, and again, that's all going to come back onto the heat customer. And there was no focus whatsoever on energy management or efficiency of these systems. So it's only really been in the last 10 years or so that we've actually started properly measuring the efficiency of these systems. And some of them would have very, very poor performance. Unfortunately, there was a bit of approach with when they were built on day one. As soon as they're commissioned, if they're hot, it's working. And a bit of a hands-off approach from then on. So it would almost take care of itself. And a lot of these systems, I suppose, learned the hard way on that. Again, the structure of the ESCO model that was employed, I think I've touched on that. Just there was a wide variety of thoughts and approaches at the time that may not have been, I suppose, suitable. So if we look at where we are now and maybe some of the lessons that we've learned, moving on to a more positive note, I suppose, well, just to take up from my last point around the ESCO models, we will be quite strict in regards to employing transparent and flexible models, or what we might refer to as an open book model. So Kaizen as an operator will be paid a set fee to do everything in regards to the operation management of these buildings. There's no there's no hidden profit margins. There's nothing in there. So basically, if we do everything right, the systems are efficient, our procurement is right, the cost is going to come right down. And if we have a drop in, say, our gas costs, for example, or we get a really good procurement deal, that saving is then passed through to the heat customer. Whereas previously, there was I suppose, it was a bit of a grey area in regards to that. So we've really simplified the models that are employed, and I think it's working quite well. So you've obviously had the I suppose progressions in our building regulations, Part L and onto NZEB, and you had then a desire from developers who are building these buildings to achieve the highest possible BERs, so they want to make their developments attractive as well. So it's led to much better designs on these buildings. It's forced everybody involved in to have the conversations, ensure that our capacities, our design loads are correct, that they're realistic, which is something that is quite simple, but is sometimes very easily missed. I suppose you might have heard a bit of focus on the return temperatures and making these systems dynamic and VSD pumps. That is only something that, again, as we've really only started to concentrate on maybe in the last 6, 7, 8 years. And it's huge, the benefits in terms of just that the reduced heat loss within the building, restricting that overheating of the actual building itself, and that all materializes in cheaper fuel bills for everybody. So the equipment selection is very important. So again, if I was to take that back to say 10, 15 years ago, a lot of these networks that were put in at the time would have been gas-fired boilers, predominantly gas-fired boilers, some biomass, and the boiler just would have fed a heat network. So whereas you had movements in Part L over the last number of years, which required I suppose the introduction of CHP into that mix. So your CHP would have been your lead, supplying the electricity to landlord lighting, pumps, and then I suppose that cheap heat source then into the heating system backed up by gas boilers. That worked really well, and for quite a number of years we've seen some great advancements in that. And then I suppose now with the introduction of NZEB, we've had to try and improve that as well. So we have now the introduction on a lot of these local systems of, we've introduced heat pumps plus CHP plus boilers, and it's actually good timing if you think about it. So there's been so much focus on energy efficiency in these buildings in the last couple of years that a lot of, I suppose, what we might have had as previous lighting loads or pumping loads on the electrical side has actually disappeared. And we may have had CHP capacity sitting there idle. Whereas now we know we're going to have a low electrical load, but when you introduce a heat pump into that, the mix between the heat pump, CHP and gas boilers, it's turning out to be really, really well. I suppose the smart metering systems we're all aware of the advancements in technology, which is a positive for everything. But just in general, in terms of trying to get that data out of the systems for both ourselves as operators and for our heat customers, making that data available to people so that they can in fact budget properly. The loggers that we're seeing now are and the metering, it's all really, really smart. The solutions now are coming out these days are really, really good. So I suppose in regards to some positive outcomes on that, which I may have touched on, I suppose what this has mainly led to is a reduction in the overall cost of running these systems. So you're talking about better built developments with a lower demand for energy, first of all, which is a plus. But the actual system itself is a lot more, the design focus in regards to the efficiency of that system, the return temperatures now is far better than it was a number of years ago, which has led to a significant reduction in cost, which is good news for everybody involved. Like we want happy customers, and if we're doing our job properly in terms of maintaining these systems and trying to get that near 100% plant reliability, and it's cheap to run, you know, you're ticking nearly all the boxes there. The longevity of these systems, I do genuinely believe now that the systems that are going in recent years will sustain the test of time a lot better than systems that may have been put in there maybe 10 or 15 years ago. It is simple things in regards to even having the foresight to be able to, I suppose, put a set of valves in so that we can be able to swap a pump head around very easily, whereas maybe, as Paul touched on, you might have to do a partial drain down of a system to do something like that. But we've learned an awful lot of those lessons, and I suppose the longevity and the flexibility of these systems is absolutely key. So, you know, over the management companies and the owners that we're dealing with now understand that there's flexibility built into these systems, so that if we're looking at a system that is, say, has only got gas boilers and CHP, we're now actively trying to look at, can we in fact introduce heat pump solution into that, and without having to do any massive retrofits, then you have the flexibility to do, which is obviously a significant plus. I suppose heat networks are now becoming more recognized, or again, 10, 15 years ago, this would have been very, very new for everybody moving in. A lot of confusion around, is it gas, is it electricity? No, it's in fact heat. So it is becoming more recognized now. I won't say it's become the norm, but it is certainly moving in that direction as well. I suppose you do have customers or residents or new apartment owners are in fact looking at this area now. So there are conversations coming back through from potential purchasers of apartments back to developers in regards to how sustainable is the development. What are the credentials that they're buying into? They want to understand, and they want to be able to say that they're living in a sustainable development, and what sort of an impact does that have to their own carbon footprint. There are conversations that maybe 10 or 15 years ago, they would have never ever happened, and it's great. So it's pushing everybody in the whole supply chain to really up their game, which is great for everybody. I suppose just my last slide in regards to some challenges and opportunities. Some of these you'll have touched on already, or you've seen previous presentations. So you'd have seen John's presentation from Codema in regards to the Dublin District Heating Network. So we have there's a huge amount of buildings prime waiting on that supply to come in, which is good news for both sides. It's good news for the heat network itself when it does get running, that it doesn't need to wait on its customer base to come on board. They're sitting and waiting, and there'll also be a positive then to the local heat network side. So you're going to, in terms of reliability, you've now another option in terms of your heat source. You would hope that it's going to be obviously a lot more sustainable, and you're also going to have the idea of maybe reduced costs as well. So they're all really, really welcome benefits, and you know, the more these networks to go in localized, the more opportunities there are to in fact join them up into larger systems as well, which is now becoming a little bit of focus, which is good. We need to incentivize these systems with on the current building regulations. Whilst they are getting through the current building regulations, it's not as streamlined a process as you would like. So for example, if there was a mixed-use development going in, maybe beside a large waste heat source, such as a data center, for example, it's very tricky to try and get that through the deep software in order to try and get compliance on that. So it's a little bit counterintuitive, and I think that's an area that really needs to be looked at. I think it is, but I think that the easier we make this for all of the stakeholders, be it developers around and consultants looking at concept design and looking at their options, the easier this option is, the better for everybody. And improve the heat sources. So again, I touched on, I suppose, the flexibility of these systems. So this is only not only from a new build perspective that we need to look at what that generation mix is going to look like. We've spoken about heat pumps. We've got now renewable gas coming online into the grid as well. You've got options around solar thermal if you've got the space, green electricity, and even that waste heat. So as John's presentation quite clearly showed, there's a huge opportunity here to bring waste heat sources into these systems. So we kind of see this as a real area of kind of improvement over the coming years. Bit of an obvious one, continue to increase carbon taxes. That really, I suppose, focuses everyone's attention on ensuring that the system that is going in, or the system that maybe a developer is going to choose, is going to be carbon friendly. I suppose you will hopefully see a shift in the industry in regards to the European Green Deal over the coming years, and that's only going to, I think, react positively in regards to this industry. And I suppose the last one that I will touch on is as I said, even 15, 20 years ago, this was an area that was not regulated, and it's still not regulated. So there, I suppose, even from a customer protection point of view, there's very little out there in order for them to go to, as it's not a recognised utility. So I think over the coming years, we need to commission for regulation of utilities, the CRU, to in fact recognise this as a utility. Like I would think in a short number of years, you're going to go from having maybe 10, 15,000 residential heat customers to probably multiples of that. And I suppose now is the time to really try and regulate that area before it gets out of hand. Look, that's me. Thank you for listening.
That's brilliant. Thanks very much for that, Fintan. Very interesting to hear, I suppose, and lots of lessons that we can learn around the customer experience on schemes that are already up and running. And I suppose you highlighted there as well how these schemes and these buildings are future-proofing the customer connections for bigger schemes. And we do have to overcome the issues internally in the communal schemes and in those buildings in order to connect to bigger networks. So any questions for Fintan, please do put them into the question and answer box. Fintan will be happy to answer them at the end of this session. So just to introduce our next last speaker of this session, but by no means, we're very happy to welcome one of our newest IrDEA members and our first cooperative community member as well. JP Prendergast is chair of the Clare Morris and Western District Energy Cooperative, and he's also founder of Community Power and is also chair of Renewable Gas Forum Ireland. So a very busy man, and we're very glad to have him here with us. He's also working on the Interreg project BioWill, which focuses on integrated zero waste biorefinery. utilising all fractions of willow feedstock for the production of high to medium based biochemicals and materials, and renewable energy in the form of biomethane production and others. So, JP, I'll hand over the floor to you.
Thank you, Donna. Can you hear me okay?
Yeah, we can hear you loud and clear.
Super, okay. And can you see that screen okay?
Yes, that's perfect, JP.
Super. Okay, Donna, thank you very much, and thanks for having us on this call. Our presentation is slightly different, whereby we come in as a community entity here with a real interest in district heating. We've had this interest in district heating for a long time in Clamorstown and beyond, and I suppose some of the work we're doing with other communities is becoming more. Communities themselves become more aware of technologies, their impact, and certainly the future in addressing certain on our climate action targets. When I was asked to give the talk, normally when I give a talk and I mention community, half the audience will turn this way and half the policy and government guys will turn that way. As I see, community sometimes has been a small thorn on the side, but however, from the point of view of moving forward, community involvement and the participation of communities in renewable energy, particularly addressing the heat demand, such as district heating, is becoming more and more important. When I looked at this initially, I wanted to address probably why communities and the importance of community initiatives in decarbonisation, and particularly meeting on low carbon technologies, was so important, is this transition to the whole Paris Agreement. I suppose with the Kyoto Protocol at the time, we would always regard this as from a life cycle analysis as above ground technologies, as in supplying and on the carbon life cycle, where Paris is now a more integrated approach in the whole circular economy, but also in the life cycle analysis and the carbon life cycle analysis of above and below ground processes, which has, in its own extent, an impact on the environment, from waterways to transport to soil. One of the most important things when we speak about communities is that we have to understand that there's a right mix of technologies. It's not one solution. So where biomass will be the optimal solution, you may find heat pumps may be better on another site, or for example, a combination of biomethane might give you an overall community mix. So what you're finding at this moment in time is the community looking for the optimum solution. This presentation won't be into the actual technologies. What this presentation will look into is how we are trying to enable communities outside of the big cities to address district heating and be able to, I suppose, start to build these type of networks. When I talk about communities, you know, Ireland is only a small country in its own ways, but if you look beyond UK of 400 community groups, looking at, again, low carbon communities networks in UK, Climate Action Fund Group in Scotland, who are very proactive, especially in the development of green hydrogen. Netherlands with 35 standalone community groups. Poland is now looking at what we call the EU-wide city energy cities initiative, incorporating district heating. Denmark, as we know, been one of the leaders in district heating, but also community-owned district heating. Germany, 65% of renewable energy is community-owned. The French now are looking at low climate energy interests in regards to populations over 50,000, and communities being the lead in understanding and deploying these technologies. Eco-villages in Spain, for example, and also from being at home here, we actually have our own eco-village in Cloughdordan there in County Tip. But over the last period of time with SCAI, they started this initiative about maybe 3 or 4 years ago of establishing what we call sustainable energy communities in Ireland. We have now over 400 sustainable energy communities in Ireland, and each community was given the task of producing an energy map for the locality. And as part of that energy mapping, they would then suggest relative solutions to how to address both the energy demand from both the electricity, but also heat demand within the localities. And to this extent, we're now finding that this pathway is now looking to develop these technologies and I suppose to enable communities to take ownership of these technologies. We set up Claremorris Domestic Energy District Co-op about maybe 5 years ago. We had 7 members. We wanted to look at a number of impacts within society, which was renewable energy within society, and particularly the impact of climate change. We had experienced probably the negative and the NIMBYism behind renewables in regards to, at the time, biomass and biogas, which was completely I suppose, unfair at the time. And because of that, we felt that the education and the information awareness wasn't out there to at least give communities that opportunity to develop these technologies. Not only to exit in some ways an energy grid, but become self-dependent, developing green jobs with communities presenting over, at this moment in time, we've over 100 members now in that short period, but we probably developed beyond Claremorris to a number of SECs around the country, working with, at this stage, 9 county councils, looking at their heat mapping and also the possibilities of district heating becoming an enabler within those locations. The co-op in 2017, the first success was an innovation fund with Gas Networks, where we basically built a trailer, and in that we displayed a number of technologies, from anaerobic digestion to understanding the base of biomass, thermal and solar. And as a consequence of meeting these different communities, we found that we were asked a lot of questions on the technologies and how to roll out and integrate these technologies within communities, and hence in 2018 we set up Community Power. And I'll refer back to Community Power later on in the slides. In 2020, the group, we were one of 7 of the successful applicants under RES 1 for the Electricity Support Scheme, RES 1. We were one of 2 which were 100% community owned, and the second project we have in Galway, we were part of that project as well. So I suppose we have progressed in the 5 years. I would hope to become very credible in our I suppose roadmap in the application and deploying of renewable energy technologies within the west of Ireland itself. Our interest in one of our first projects in Claremorris, which we started looking at and now going out with a Part 8 planning application with Mayo County Council, is a district heating network. We have natural gas, we have gas in Claremorris, but we were able to justify a mechanism whereby the district heating became an extension of that gas network into localities within the town which did not have gas. So we generated a roadmap, a kind of a mapping of the town with Tipperary Energy, and we developed this map as you see in front of you here. So we've used this from our swim pool, which is our heat stabilization mechanism, and then we work backwards from local library to Aldi, Tesco's to Mayo County Council buildings, but also we incorporated 30 social houses within that network. We know from our feasibility that we've been for benefit of removing probably 600 tons of fossil fuel generated within the town on a yearly basis. We know that we have a viable wood chip supply within the locality, but also to support that with a biogas infrastructure. To us as a small town, it generates probably about 200,000 extra revenue within the town itself, generates 5 jobs. But what it does is becomes an enabler. It becomes an enabler because meeting with communities, the district network itself, district heating network itself, becomes that enabler. The technologies that we use at the end of that, or where we generate that heat, will always change. But that network, that enabling network, now gives us a chance to focus and centralize at one location our heat generation, and then probably move that benefit out to each building accordingly from that one location. But the real benefit to us here is that we're now able to look at generation of not just heat, but power, and offer that whole solution within our town. So it's not just that the district heating provides the heat, but it also provides a platform and the advantage to their end users that not only can we do the heat, but we can do power as part of our solar project. And I suppose this is where I had to look at probably the energy initiatives which are community driven and community led or community participated, and these are the enablers. So one of the projects, the first enabler that we see actually started as a community project was actually the BioWill project that you referenced, Donna. BioWill is a project where a number of communities got together in the west of Ireland wondering the future of the forestry and short rotation crops, and asked what we call from a life cycle analysis and circular economy, could we extract value from that biomass before it was used to produce renewable energy? Work that we've done ourselves is we actually extract salicin from natural willow, which is an aspirin. It's a natural aspirin. And it's already been shipped in a product to about 27 countries around Europe at this moment in time. The pulp, because we extracted, we produce a pulp, we're now able to produce a kind of reusable trays. But the interesting part about this from the economy drive is that we're now able to put this into a biomethane regeneration gas, into an AD plant, and we're now able to use that material in combination with slurry to produce a methane. And so this is the enabler for the district heating, whereby in some ways this now becomes our waste heat, our waste source. We now can enable that mechanism of using that methane within Clamars Town, Galway City, Longford, Limerick, Mullingar, to now look at district heating centralised at one location using a biomethane from a project such as Willow on a biomass orientation. So this was actually a community project initially, which looked at how can we, as a town, supply our own energy into this network. How can we generate our own biomethane to address that heat demand? A second project, which a lot of people will be aware of, and we've worked with Rory Monaghan, is as associate partners and community, is GenCom. And this is on at the hydrogen mix within Ireland. And the interesting part about the hydrogen is you can produce that from your biomethane generation. And this becomes, again, a source for your heating, or a heating plant. So as a community, we're now capable of looking at generation of hydrogen to meet that demand for smaller district heating networks around the country. And particularly in the location of rural Ireland who are off the gas networks or do not have the access that would chip accordingly. Interesting about this one is that because of the generation of the hydrogen, green hydrogen, there is now a lot more interest in communities on the future of district heating. And I think really getting to understand the value of what the network presents, it's the enabler to attach this new technology onto it to produce that heat for the town or community itself. A third project that we give an example in rural Ireland, how we're looking at producing a mechanism for district heating is Project Clover, and this is actually a community of farmers working with the cooperatives in rural Ireland, looking at what we call the transition to net zero carbon 2050. This is a mechanism by which products we produce, according to the Paris Agreement, looking at the carbon footprint of product itself, produces a waste, in this case the biomethane, which is then either used within that locality for the dairy or for the cooperative, but also it's now attracting communities to attach to the mechanism of using that biomethane for district heating. So on the three projects we've got here, you find that the communities are now looking at the generation of a methane or a biomass or equivalent to now enable us to develop district heating within the locations which probably wouldn't have a surplus amount of heat available to use. The interesting part about this is to enable communities is we looked at 2018 setting up an entity which was a non-profit entity called Community Power, which enabled communities. What we wanted to do was we wanted to put together a partnership of community energy groups that were interested in not just owning just wind turbines, or they're not interested in owning just again biomass, biomethane, heat pump technologies, but they wanted to probably take the profits from such projects and resurface back into those communities, invest into those communities. So Community Power became an entity whereby we have now over 150 members. We have projects ranging from hydro to wind, which was the first project we incorporated, to now our solar, to now looking at biomethane, and our Willow project on the biomass to support these communities. The interesting part about it is that our projects are quite small in regards to the Stradbally hydro turbine, where in the case of the solar in the west of Ireland and beyond, we have some large projects coming online, and now we have over 150 applications on solar alone in Ireland for communities who want to look at that mechanism of not just electricity but also heat within that locality, and supporting projects such as district heating. The interesting part about community power has now evolved to look at low carbon technologies, and specifically is now looking at focusing on delivering and enabling communities to understand what district heating is all about as a delivery medium. In other words, can we look at the justification of a district heating from an already industrial state to extend out to include social housing, to include the local swimming pool, etc. And this has become really interesting because a lot of the communities are understand the need now. As Fintan said earlier on, they understand the need that's out there for the transition of understanding the renewable energy and the impact on their society and on their environment and their community. So community power in itself now is not only just looking at the district heating, but the circular economy associated with that district heating. So the community and this initiative on rural Ireland is slightly different to what's happening probably in the larger cities. What we have to do is, to enable this to happen, we have to build the infrastructure around this. That's generating the biomethane, optimizing with the groups of IrDEA, the biomass, looking at the heat pump, looking at that whole technology mix, which is now, I suppose, incentivizing, but also switching on that interest in that sector, particularly with the probably, and Xavier is going to go on the next presentation, the failure in government to address those heat targets will require these projects such as these to come online and support rural Ireland as much as the larger cities in Ireland itself. And so community power has now got over, I think it's now established as a large-scale electricity provider. So not only do we generate, we're actually selling as on the same base of electricity. The difference is that the profits within that community stay within that community, and then what we're doing is we're then enabling them to generate revenues to research these projects, to invest in their networks, and then to build as prosumers rather than consumers on this network. There is an interesting thing on Netflix at the moment, Kiss the Ground, Woody Harrison's on it, whereby he looks at the regeneration of agriculture, and because outside of the larger cities, agriculture is such a key part to the economy, it's interesting to understand that transition, incorporating technologies such as district heating, and I think the importance of that community involvement. And it's my slide, to finish up on decarbonising heat through low carbon driven energy initiatives, those energy initiatives, as shown, is now starting to enable communities to get involved in technology implementation itself, but also because of the circular economy and life cycle analysis. In other words, from cradle to grave, we're able to establish a value chain to that material and produce a medium such as natural gas, as a green gas, or a biomass that's used to generate a product that then leads to an element of supply to a district heating network. District heating itself is becoming a new generation. When rural Ireland, we're starting to understand it better now. We're starting to understand the new generation of district heating. We're understanding the advantages that it gives to our town, our localities, but also in the mix of technology, we're starting to understand how we can make it viable. And projects such as those energy-driven initiatives there mentioned is enabling us to do that. But there is one point, and I think it's awful important, when we develop these projects and I suppose to advance on the climate justice, as we call it, and share those benefits and burdens, is that communities need to be involved in the design, planning and implementation of this, what we call transition to zero society scenarios, design of these projects on the larger scale, because not only is it what we call the fairest approach, it is by far the fastest approach, because once you have that involvement and community have an understanding of that value, I think the rollout of projects such as district heating, those enabling projects, will become so much more simpler and much easier to understand. So yeah, that's my presentation. Thank you.
Brilliant. Thanks very much, JP. Very interesting to hear, and it's great to highlight how district heating can support smaller towns and communities, and it's not just a big city solution, which is often seen as. And also, it's great to hear about the different sources, different technologies that can supply district heating. Again, we get a lot of questions around, well, we don't have waste heat here, so it's not suitable. And again, you've kind of highlighted how that's not the case, and district heating can be suitable for small towns and utilising like local resources, as you say, like biogas, biomass, etc. And great to see another European project being highlighted again. European projects are a great way to support smaller schemes, getting schemes up off the ground, and has also benefited the Dublin schemes to get those off the ground. So I'd like to welcome back then all of the speakers from that session. As mentioned, we will have a kind of a final presentation from this particular session, like on the Irish experience, from Xavier Dubuisson in the just after the coffee break later on, and it's a very interesting presentation on the results of a renewable heat plan for Ireland, which I'd definitely recommend tuning in for. But we've had a lot of questions in now for the speakers so far this morning, so I will jump straight into those. So we will start with a question for John. So John, a question has come in on the geothermal report. So there's been an assessment for geothermal energy for district heating in Ireland, a report that was released by GSI, Geological Survey of Ireland, last week. And the question is, how much interest does Kadima have in the baseload heat source cited in this report, as they mention Kadima frequently in the Dublin system potential?
Yeah. Well, I would say we're very interested, as we are in all low carbon heat sources. And I suppose through the kind of work we've done mapping these sources, we can see that geothermal energy is a significant resource. I think it accounts for about 10% of the heat sources we identified. So yeah, I mean, I suppose the thing is, as well as it's, it provides kind of a lower risk in terms of security of supply over long durations, which is might be a worry for some, say, industrial sites. But then I suppose there is some uncertainty about what's happening with the subsurface and whether we can get the flow rates we need to utilize that heat source. But the GSI are working to kind of fill that knowledge gap, and I know there's been a lot of studies done recently in the Dublin area to kind of help bridge that gap. And I suppose there's a certain rationale that we're kind of looking to follow now, that maybe more detailed exploration will take place in areas where there's already district heating networks or planned district heating networks, so that if there is a resource there, then you just connect it in, and it's it kind of proves the concept directly after proving that there's heat there.
Great, thanks, John. We'll take a question for Paul. So a nice technical question for you, Paul. This is what you get for having lots of numbers on your slides. So it sounds like the control system is very well advanced compared to what we see in other large heating systems and networks. How granular does the metering and controls go? Building level or more granular? And to what extent will the delta T control be viable within specific areas within buildings?
Yeah, I suppose, yeah, we would have we have a lot of data. We have a single site BMS that we developed ourselves in-house, and we probably have about 60,000 data points on that. So, yes, we can look at delta T's on secondary circuits. We would have that level of data. In general, might be a few where we don't have a return sensor, but yeah, the data does exist. We do have it. So, and it's very useful for balancing, really,
Great, Paul, that's brilliant. So we might go to a question for Fintan now. So Fintan, a question in, first off, says great presentation. And then what is the average cost per apartment for heating and hot water?
Well, I suppose it would vary depending on the age of the development. But I suppose to stick with, we have two developments that we've recently taken over that are NZ compliant. So these will be designs that I've spoken about in regards to air-to-water heat pumps with CHP and gas-fired boilers then as almost as backup. Again, that mix within that model has led to it's really competitive at the minute. Now, bearing in mind gas costs are very low at the minute as well. But I suppose we're modeling them first of all based on kilowatt hour consumption for, say, a standard 2-bed of in and around about maybe 3,500 kilowatt hours a year, and you're looking at an average cost of, again, for a 2-bed of somewhere in the region of 425 to 475 euro. Again, that's just round figure estimates, but that's kind of your guide for your cost these days. So and that's a full inclusive cost, by the way, as well. That accounts for the operation, the management, the maintenance of the system. That's a self-financing model. So there's no, I suppose, a secondary cost for a management company to pick up. That's all in for that.
Yeah, I think that's important points, Fintan, as well. Like the cost, like, you know, you have everything included in there, your maintenance, you don't have to worry about breakdowns and that kind of thing. So it does, I suppose it's a real overall service provided to the customer rather than, as you say, just the heat. So we have a question here for JP. So JP, if you have DH pipes in the ground, or if you're planning, I suppose, the pipes in the ground, do you have any issues around planning for the installation of the pipes in the road, planning permissions or anything like that? If you could highlight any of those issues.
Donna, what we did with this project is we've actually done a partnership with Mayo County Council. So a number of the buildings have been built over the last 5 years. What we did was we met with the HSC on their primary care building. We actually allowed for that ducting to be put in place as the build was going on. As regards to the ducting there, the ducting will be done in partnership with Mayo County Council. So I think it's often important that involvement is there. I think if we just stand alone and try and do that, it would be more difficult because they're able to advise us very quickly, and also because they take an ownership on it with us, it takes some of the pressure off us, but also makes sure that the planning is proper and that process is done correctly. So it's not a big network in a sense, but it is, it is perceived as being an obstacle, an issue by people digging up those roads. But they'll look beyond that once the tarmac's down again. And with technologies, you're not digging as far as you would have had to do in other locations.
Yeah, that's great. Yeah, so it really highlights, I suppose, the role of the local authorities again, and how partnering with the local authorities really helps to kind of drive these projects and get them over the line. That's great. So there's a kind of more of a comment for you, Paul, that there was rumours that those tunnels under UCD were used for as student escape hatches or staff escape hatches away from students. So you've confirmed the rumours apparently that those exist.
Yeah, we use them all the time.
Good to know. Good to know. Yes, we might have a question here back to John. John, how will the disruption associated with installing the distribution network be managed? So, for example, in like dense urban areas like Dublin City, around Poolbeg and that kind of thing, they'll involve a lot of road closures, roadworks, etc. And same for Intala. How are these going to be dealt with?
Yeah, well, I suppose the first thing is to engage with the highways team. So we'll be working with the highways department within the local councils to kind of coordinate the works. I know, like for instance, in the Tala scheme, we've installed some conduit to allow the pipe be installed at a later date without having to dig up the road again, because there was roadworks taking place there. So we kind of took the opportunity to put conduit in. Yeah, and I suppose when it comes to kind of developments and stuff like that, like there is trench sharing opportunities with developers. So if they're putting in fiber optic cables, you can dig one trench and put in the district heating pipe and the fiber optic. And I suppose in terms of disruption, yeah, it's like any utility, you'll have to have your traffic management plan and all that kind of stuff in place to minimize all that.
That's great, John. And again, I suppose working with the local authorities has its benefits as well, because they're well used to, putting pipes in the ground as well and closing roads and all that kind of thing. And so again, it's great to have their experience at the table. So we've time for another couple of questions. So I'm just trying to see what else has come in. John, you've got another couple here, so I might come back to you. So the question in on the megawatt capacity of the backup electric boiler for Tallaght. So what is the megawatt capacity, and how long does it take to get to grid capacity? Was there any delays on connections there?
Yeah, so the backup boiler is 3 megawatts, so it's 3 megawatt boiler. And I suppose the good thing about that is that it actually provides an opportunity, or a significant opportunity, for grid balancing, which we've also got contact on. In terms of time, I can't remember what the time was, but yeah, I mean, it's always a good idea to kind of front load something like an electrical connection, because they can take a few months sometimes. So yeah, it's something to think about in the scheduling.
Yeah, and particularly obviously for that side, if there's the grid capacities also need to be there for the heat pump, for the large scale heat pump, as well as the backup electric boiler. But I suppose being in a location where there's already a large data center, there's always like large electricity lines coming in there in terms of capacity in those areas to support like the data center. So hopefully those kind of issues won't come up in terms of grid capacity.
Yeah, and backup grid lines as well. I suppose there's
exactly.
sort of a triangle of redundant electricity cables there. So yeah, it wasn't a huge barrier for us.
It's a nice safe area to put your electrically driven heat system. So there's another question here. Then I'm just trying to keep up to date with all the live questions that are coming in. Again, sorry, John, it's back to you again. So I suppose it's a general kind of interest one, but in terms of the cost of waste heat, so supplying waste heat versus individual heat pumps. So in terms of the cost to the kind of the real estate owner or the developer or the end customer, how does waste heat compare to running local heat pumps instead?
Yeah, well, I guess, yeah, it compares quite favorably. I think we did some analysis as part of a kind of brochure we developed for developers actually on the Tallaght scheme. I think it was about half the cost when you kind of factor in things like, the kind of floor area saved. So obviously with individual heat pump installations, you generally have, your kind of hot water storage tanks. And, even if it's just a square meter, it's, in Dublin for a building department, I think it's about 2,300 per square meter. So if you start adding those together, it makes sense. But then when you start looking at the Part L compliance, and your counterfactual being heat pumps, when you're looking at individual heat pumps, they can be quite expensive. So you can kind of take advantage of that kind of economy of scale with the district heating network. And then I suppose the developers themselves, like the kind of improved reputation and the higher renewable energy, and as I said, the opportunities for trench sharing, and noise and all that kind of thing. So like heat pumps, I think they're around 40 or 50 decibels. So it's kind of similar to kind of light traffic or kind of conversational kind of speech in terms of noise level. And then there's lower risk in terms of carbon monoxide and gas leaks, and lower maintenance costs as well as the heat price itself being competitive.
Great, thanks, John. So yeah, it's obviously got lots of other benefits as well as being price competitive. So there is a question on EPA licensing for I presume it's to do with the waste to energy plants. I don't think the speakers will be in a place to kind of answer around that, because we're just taking the waste heat from that plant rather than any kind of licensing issues around that. So actually a question for Fintan. So how do you feel in terms of the appetite for district heating from developers? What's it like out there for developers now? Are they interested in communal or district heating systems?
Yeah, it's a bit of a change in landscape, I suppose, and that market in itself has obviously changed in the last couple of years with PRS, the move towards the private rental sector, with large institutional investors coming in and buying developments off developers. But I suppose that I think has actually pushed it more towards the communal heating network option, because these systems have longevity. So if you install a communal heat network, and you are a long-term investor into these apartments, and you even take, say, a 10, 15, 20-year view on that, you know, you've relatively small amounts of period, where if you go to some of the individual options that are available within that 20-year period, you're potentially talking about replacing those individual options twice over that. So the life cycle of these systems is, it's a bit of a no-brainer, to be honest with you, when it's weighed up against the other systems. Look, there are developers out there that have a very good reputation, and they take the time and put the effort into looking at what the best solution is for the development. Luckily, a lot of them are going down this route. And then there are developers out there that, I suppose, maybe just are completely focused on bottom line, not really looking at what is the end user or the resident, what they're going to be left with. There's no real focus on that. They do go with various other options. But thankfully, a lot of the housing stock seems to be going down this route, which is good.
Great, thanks for that, Fintan. And we'll go back to another question to John. So you mentioned in your presentation the involvement of seawater in district heating. Could you elaborate further on this, please? And is there any practice, is this practice carried out widely in Europe?
So yeah, it has been adopted in a few places in Europe. Off the top of my head, I know Drammen in Norway is one place where they've installed it. I think it's maybe a 10 or 15 megawatt heat pump system there. I think The Hague as well in the Netherlands has installed one. Astrid isn't on the call, so she'd know the answer to that one. But yeah, no, it's an interesting area, I suppose. You know, it's essentially an inexhaustible heat source, you know, given the volumes of water. But there are, I suppose, certain issues that have to be considered around it as well in terms of operation and maintenance, like filtering and stuff is very important so that you don't get, you know, a load of limpets living in your system and all that kind of thing. But yeah, it's an interesting opportunity. You know, there's potential maybe for, you know, floating energy centers. You know, there's no groundworks needed. You know, it goes up and down with the tides. You know, which looks good. Maybe throw a cafe on top, and you know, so yeah, so there is opportunities, and with the offshore wind that's coming on stream as well, could there be potential to use them as another means of energy storage? You know, at the kind of landing point.
Yeah, that's great, John. I think I remember a story from Denmark where they were using water from a fjord, and there were eels swimming up into the heat pump to get a bit of warmth in the winter and stuff. So so yeah, there are obviously issues in some of the schemes, but obviously they're getting over those kind of things. Yeah, obviously, you know, with our big cities like Cork and Dublin on coastlines, you know, seawater is a good source that we should be looking at in combination with heat pumps. So yeah, I think we've got through all the questions that most of the questions. There's a comment there, more of a comment on another rural example, and an energy community in Dingle, which is kind of looking more at electrification. But maybe JP, that can be your next. Not that you haven't got enough to do, but that could be one of your next community schemes to look at a district heating system or a district energy system in down in Dingle. Well, if at least anyway, they'll learn a lot from, I suppose, the Claire Morris experience. So yeah, I suppose we'll wrap up this session now. So we're going to take a 15 minutes tea and coffee break. Unfortunately, we won't be going to the hotel lobby, so you'll just enjoy your trip to the kitchen. And we'll see you back here at 11:30 for the second session, which will be hosted by Brian Montaigne of the ESB. Thank you.
Hi, Brian. I can't hear you.
How are you?
Great. Are you ready for action?
I'm ready for action. Have you got yourself sorted, yeah?
I think so.
Yeah, there's put my headphones on so I'm a bit more,
Sure. Yeah.
a bit clearer maybe. But you sound better. I don't have, I'm waiting on a set of ESP issue headphones for about 8 weeks at this stage, and I don't know what's going on. But anyway. I'm using so I have to use, and I can't use Zoom on anything other than my personal device. They don't let us use Zoom, you know.
Okay.
So
I have to say I got I think they're called Jabra, and they're very good. I have to say.
yeah, I don't think the ones we're getting are Jabra. They were the ones that were recommended, all right, but
yeah,
I think we have procurement. We get procurement rules thrown at us, so. Just check my.
The numbers are good, aren't they, overall?
Okay, looks like we're on.
Yeah.
It's not quite 11:30 though, is it? According to my clock. Yeah, we might just Suzanne there, whether we want to, or Dana, whether we kick off or wait a couple of minutes.
We'll just wait until 11:30, Brian. Then
that's fine. Oh yeah, no, I just looked at my clock here. That's fine. Perfect.
Yeah, no problem. Just to let you know that all the attendees can hear the conversation.
Yeah, no, I saw that. Yeah. Yes, indeed.
We have to be careful.
Yeah.
I've just put some notes, Brian, into the chat box for you as well.
Okay. Thanks, Suzanne. Okay, welcome back. Brian Montaigne is my name from ESB, and I'm delighted to be chairing the conclusion of session 1 and session 2 this morning. I'm going to start off by introducing Xavier Dubuisson from XD, Sustainable Energy Consulting. Xavier is going to talk about the results of a renewable heat plan for Ireland. Xavier has 25 years experience as an engineer in the field of sustainable energy, both in Ireland and internationally. Has come from Belgium in 2001 to work with SEAI in the Renewable Energy Information Office, where he was instrumental in the rapid expansion of the Irish renewable heat market. He's one of the leading experts in energy systems modelling and has contributed to pioneering energy planning initiatives by local authorities and community groups across the country. Xavier also provides ongoing technical support to IrDEA, and he is currently completing a study aiming to develop a renewable heat plan for Ireland on behalf of a number of renewable energy associations. And I can say that I've had first-hand experience of seeing Xavier in action, and nothing but impressed. So with that, Xavier, I'll hand over to you.
So I'm okay.
You're on now.
You can hear me now, and you can see my slides to you.
You might put them in the slide screen. There you go. Yep.
Okay, cool. Great. Well, thank you so much, Brian, for the introduction and your kind words. I hope the results of that labor of love of the last few months will be of interest to you all. As Brian mentioned, we started a study, let's say around May, on behalf of a number of trade associations in the field of renewable heat, including IrDEA, the Irish District Energy Association, as well as Renewable Energy Ireland, and a number of, let's say, member organizations and associations. The objective is to, or well, it's still, because we're still working at it, to develop a renewable heat plan for Ireland with view to inform policymaking and market development to bridge the big gap in terms of where we are in terms of renewable energy penetration and where we need to be, not just for 2020, but definitely in terms of 2030 and then 2050. The challenge is huge in terms of decarbonization of heat, and I'm sure you've heard about that from previous speakers. So the specific objectives of the study, first of all, was to understand really what is heat and how we are using it, and then project what heat demand would be in 2030. The next step was to look at renewable energy resources available to meet our heat demand nationally, looking at indigenous resources, and then to model different scenarios or pathways for the development of renewable heat and its contribution to our national heat supply and overall decarbonization efforts. And out of that process, recommend a pathway for the decarbonization of heat in Ireland, and looking at, let's say, measures and policy support to enable that. I think it's very important to mention at this stage that let's say the renewable heat plan and the study has been a very strong collaborative effort, and we've had very regular engagement over the last few months with let's say the stakeholder committee that is overseeing the study, and there's been a lot of exchange of information and contributions from all around, and I think it's well worth mentioning that. So the first step was to try and understand better what is heat, where does it come from, where are we using it, and to do what. And in that context, we broke down heat in three ways, and the pie charts you see here illustrate that, and it's important to know that this is for the heat demand. So that's what we call the heating requirement, the useful service provided by your oil boiler, your heat pump, or your district heating system. And that's estimated at 45 terawatt hours per year for 2018. So the first pie chart shows you how the breakdown by sector, and it shows that heat usage in home is a very significant aspect of our heat demand, and it's the biggest sector in that regard. Industry is actually very significant too, and the services sector to a lesser extent. In terms of heat density, we leveraged the work of IrDEA in terms of the development of the heat atlas to understand where heat demand is, and to break it down in sub areas that have a coherent density of heat demand, what we call urban, suburban, and rural. And it's worth noting, and it's no surprise, I guess, that rural heat demand is very significant in Ireland, given the dispersed nature of our habitat, shall we say. And equally important is the breakdown of our heat demand according to its temperature profile. And within that space, we've looked at space heating demand that is a low temperature and what we would call in buildings, homes that are heat pump ready. That's quite significant, about 19%. And then the space heating demand and hot water demand that is at a relatively low temperature at 60 degrees Celsius. And you know, that's the biggest element of the pie chart. And then, you know, for the older buildings that are less efficient and where there's a requirement to operate at a higher temperature, again, that's also quite significant. In the industrial sector, we've based our analysis on the number of European studies, and we've let's say allocated 15% of processes at the high temperature above 400 degrees Celsius, and 9% at medium temperature at 100 to 400 degrees Celsius. And when we look at that, that's very useful to inform the type of technologies that we forecast will start playing a key role in meeting our future heat demand. So as I said, you know, a key aspect of the study was to understand what's available to us in Ireland to meet that heat demand from renewable sources. And this was actually, you know, not a very comprehensive study, but when you add all the different potentials we came across from different publications and reports, etc., it kind of adds up to a very significant number of 78 terawatt-hours. So, you know, significantly more than our current heat demand if you want to use that as a benchmark. It's also worth mentioning that in this analysis, we haven't included individual heat pumps as such. But when it comes to, you can see on the graph on the left that solid biomass and biogas, or bioenergy generally speaking, is a very significant aspect of our resources, as you can imagine. But the big one is surpluses from, let's say, waste heat from power plants, data centers, industrial excesses, or heat that would be produced by a heat pump, which is capturing excessive, let's say, excess renewable electricity on the network. And waste incineration has been mentioned before. So, you know, all these are very significant. And within that, and the other renewable energy resource we've grouped in there, geothermal energy, surface water bodies or sewage, let's say effluent from wastewater treatment plants, which have a low temperature, but which can be upgraded with heat pumps, solar thermal systems on rooftops, and solar thermal in district heating. So overall, you can see that, you know, there's a lot to work with. That surplus heat is a very significant element, and that biogas and solid biomass as bioenergy can play a very significant role, in particular in the industrial sector, and we'll come back to that in a little while. So a big piece of work that went on as part of the study was to develop a model that enabled us analyzing different scenarios of renewable heat deployment in Ireland and looking at the contribution of different systems in the different sectors and how that plays out in terms of heat density, in terms of heat temperature. So effectively it's a significant spreadsheets with lots of formulas developed by Shay Kavanagh and myself over the last while, which has an architecture which is quite similar to the National Energy Balance, obviously just focusing on heat, and that will be useful in terms of providing numbers that will then inform projections for future energy balance in Ireland by SCI and government. As I mentioned before, we looked into projecting the current heat demand to what it would be in 2030, considering growth, you know, in population, in GDP, etc. And you know, as you can imagine, there's a lot of variables: how much energy efficiency will we achieve, etc. So the position we took was that we take the National Energy and Climate Plan with additional measure scenario, which kind of represents what's the current policy drive and where that should lead us again in terms of renewable energy supply and energy efficiency. And we kind of deconstructed that to understand what's the heat demand underneath that. And then we assume that the renewable energy contribution will stay the same as in 2018. So there's no movement there. So we kind of start with a blank page, and then we looked at the balance, and that's where we can play in terms of substituting fossil fuels with new renewable energy systems. And the with additional measure scenario is useful in that we assume that it includes energy efficiency gains and integrates socioeconomic drivers in terms of future energy and heat demand. Then what we do is define scenarios of future heat supply by setting different proportions of heat demand met by new renewable heat systems in each sector. And then we allocate the balance of heat demand that's not met by renewable heat to fossil fuels, considering the likely substitution of these fossil fuels by resi systems. For example, you can envisage that district heating would play a role, let's say, would substitute largely gas heating on the network in urban centers, just to give you an idea, or heat pumps would be replacing oil heating in rural areas. Then for each scenario, for each system and in each sector, the model calculates the final energy consumption, primary energy consumption, CO2 emissions, and fuel expenditure. It also calculates the life cycle costs of the new renewable heat systems based on annualized capital expenditure, operation maintenance, and fuel costs. So that gives us total annual costs. And we can also derive other KPIs such as obviously renewable energy penetration, CO2 reduction, as well as more sophisticated ones like levelized cost of energy, CO2 abatement, job creation, etc. So in terms of the projection of heat demand to 2030, as you can see on the graph on the left, in the National Energy Climate Plan, there is a significant growth in heat demand, and that's largely led by industry. So it's generally foreseen that the residential sector will become more efficient, and to a lesser extent the tertiary sector, but that industry, due to growth, will be increasing its heat demand overall. And we estimate that the future heat demand would be around 51 terawatt hours. So that's a jump of 7 terawatt hours from 2018 levels. Then we looked at a lot of renewable energy systems within that, and I'll just focus on district heating, obviously, because that's the key subject of this conference. And we defined two scenarios in conjunction with our colleagues in IrDEA based on their analysis of heat demand. And the heat atlas has been extremely useful in that regard, and I encourage you to visit the heat atlas on IrDEA's website. But in terms of heat density, a very significant share of our heat demand in urban centers is at a density that's sufficient to make district heating feasible with current technology. That's about 27% of our national heat demand, and 8% of our national heat demand is in very dense urban areas where district heating is considered highly feasible. So overall, as part of that scenario, we assume that 35% contribution from district heating is feasible, and that will meet the heat demand in buildings. So industry is not considered here. And that was set as a target for what we call the IrDEA H++ scenario. and that's about 10 terawatt hours. Another scenario is less ambitious and is looking at really focusing on urban centers that have not just high heat density, but also significant surplus heat available, in particular from industry or from power generation, and namely Dublin, Cork, Limerick, and Drogheda. Within those, we assume that district heating will be adapted to meet 50% of the medium heat density bracket here, and 100% of the high density bracket, so where district heating is highly feasible. So when you sum those two potential, that adds to about 10% contribution from district heating to the total heat demand in buildings in Ireland. And that's seen as a realistic scenario for 2030, which is equivalent to an overall heat supply of 3 terawatt hours, and represent a degree of growth of 10% over a 10-year period, which would be quite typical, in fact, from when we look at the trajectory of district heating in a number of Scandinavian countries. So that's considered as a very realistic scenario for district heating in Ireland. In terms of heat supply to those district heating systems, we're looking essentially at surplus heat from high temperature sources, again, namely power generation, industry excesses, and to a lesser extent, heat from low temperature surplus heat, in particular from data centers, where heat pumps play a role in lifting the temperature profile of that heat resource so that it can be used. And then biomass to a lot lower extent in areas that wouldn't necessarily have access to surplus heat. We've considered network losses of 15%, a waste heat cost estimated at 20 euros per megawatt hour, and CO2 content of 20 grams per kilowatt hour. So a very low carbon content for the waste heat. Now, this table gives you an overview of the results. Obviously, I won't go through the details of those results. I just want to point out a couple of things. Our interpretation of renewable heat is different from, let's say, SEI's, in that we consider that waste heat is a renewable energy resource. It's definitely a very low carbon one, and I think it is justifiable to look at it as renewable heat. We also consider electricity and its contribution to our heat supply. And within that, we consider the renewable energy proportion of our electricity supply as a contributor to our overall renewable heat targets. And then the balance will come from fossil fuels and, let's say, the gray portion of the electricity supply. So what you can see at the bottom is that we're getting really good numbers for the scenarios that include district heating, and definitely for those where we're maxing out on the renewable energy supply into the system. And I come back to that here in the graph. So here I'm sparing you the numbers, but I try to illustrate how things pan out. So what you can see at the top here is the level of renewable energy penetration in the heat supply. And you can see in the district heating scenarios that, you know, we have a slight increase on the baseline with district heating, but we really have a very significant contribution when we look at the overall potential of district heating and the contribution of waste heat in particular, and which would be equivalent to what would be achieved with the NECP with additional measure scenario. So what, you know, effectively the government is envisaging. So district heating and waste heat alone can have a similar impact. When we add to that bioenergy in the form of renewable gas and biomass, especially to decarbonize heat in industry, you can see that there is a very significant drop in the fossil fuel demand. To that, you can see the very important role of heat pumps in buildings in particular, but to a certain extent in industry, and then our district heating and waste heat contribution here at the bottom. And in that case, if you add them all up, they are equivalent to about 70% or penetration of renewable energy in our heat supply. In terms of how does that translate into CO2 emissions reduction, you can see the three key scenarios here and how they compare with the baseline in 2018. And we have with the ResMax scenario, we have a very high level of decarbonization already happening. But just with district heating, you can see, oops, sorry about that. You can see that we already have a very significant impact. So when we start looking at the cost of all that, it becomes very interesting, and that's where the real discussion will start. And in this graph, I've added to energy expenditure the cost of capital and operation and maintenance costs for the new renewable heat systems. And what's really interesting to see is that, first of all, what we would look at as business as usual scenario. So our 2030 baseline, where the level of renewable energy penetration is low, is quite expensive, and results in a significant increase in energy expenditure, essentially. While with existing policy measures, the scenario number one, where very little energy efficiency is actually happening, there's very little renewable energy into the system, that's turning out very expensive. So we see a rapid increase in energy cost overall. And in the NECP WAM scenario, you can see here the impact of energy efficiency in terms of really reducing the cost of energy supply for heat. And in those two district heating scenarios, you can see that effectively there is no change in terms of overall system costs for the heat supply compared to the 2018 baseline. And that's essentially to do with the fact that we're leveraging very cheap waste heat to meet our heating requirement. And then in the ResMax scenario, you can see here that obviously there is an increase, as you can expect, is in terms of annual cost compared to the baseline, but that's the price we'll have to pay to achieve a very significant decarbonization. I'm almost done. I can see the flashing lights, so I'm getting to the end of my presentation now, and just want to mention a few next steps. So there's a lot of formulas and assumptions, etc., in the model, and we continue testing that and get feedback from the different, let's say, participants in the study. We have the ability to look at a wide range of scenarios, and so we'll be playing with the model. And I think there's a lot of there's a big knowledge gap, I think, generally speaking, around heat, and continuing to gather evidence and improve our assumptions and the model itself will be very useful going forward. We also are at a stage where we're going to start expanding the range of KPIs presented, looking at levelized cost of energy, abatement cost for CO2, job creation, etc. So we have a broader understanding of the cost benefits of different scenarios. We're going to analyze the results and collectively, and start developing key messages for our, let's say, engagement and consultation period. And as part of that, we will be looking at policy enablers and different options and measures that can make or facilitate the realization of the selected pathway. A draft renewable heat plan will be published, and then we'll be going to consultation and with all case stakeholders, and hopefully build a consensus around an ambitious heat plan for Ireland. and then we'll get to business and work with stakeholders to actually implement the plan. So that's is my last slide, and I'll leave you my contact details. I would be delighted to engage with you and to share knowledge and information in that space. And just to mention, the study, when it's ready for publication at its different stages, will be available on the IrDEA website and the IrBEA website, as well as Renewable Energy Ireland website. Thank you very much.
Thank you very much, Xavier. Just a very tour de force there of the work that you've done over the last few months. So, and I know also it'll play a critical contribution. I know that there's a piece of work going on within SAI around the national energy plan as well. So there's a lot going on around this area currently. So thank you for that. We're going to take questions for Xavier in the overall Q&A at the end. So with that, I'm going to introduce our second session, which was going to look at international policy and regulatory review and what can Ireland learn from that. Very, very strong panel to present to you, and I'm going to start by introducing Helen Snowden, who is an Associate Director with ITP Energized. Helen has 25 years experience working in the energy sector and has recently joined ITP Energized as part of the executive team to run its technology services. Previously, Helen had senior roles at CAG Consultants, Zero Energy, Garrett Hassan and Partners, which are now at the MGGL, and is editor of the Safe Energy Journal at Friends of the Earth. Her working knowledge spans across almost all aspects of the sustainable energy sector, specialist skills in regulation of networks, including the UK's OFTOs regime, the emerging district heating regime, electricity industry codes, governance, access and charging, and of course energy markets, in particular renewable energy support mechanisms, the capacity market and ancillary services markets and heat markets. So quite an array of experience there, and delighted to introduce Helen. Over to you, Helen.
Hi, thank you for the introduction. See if I can share my screen. Is that working for everyone?
I can see the screen. Might put it in slideshow.
Yeah.
Yeah, I can see it though, and I can hear you.
Yeah, can you see it now? Yeah.
It's still not in full screen, but we can see the slides.
Sorry, I had this problem before, but it's not. It's not letting me do what I did last time.
It's now in kind of, it's in kind of editor mode now, I think. So maybe if you go back to the previous version, I'm sure people can see the detail.
Yeah, let me try again.
No, there you go. Perfect.
Yep. Okay.
Thanks, Sam.
Sorry about that. Yeah, so just to introduce the work and myself, my name's Helen Snowden. I work at ITPE as of 6 months ago, but when I did this work, I was working for CAG Consultants, hence the array of companies mentioned on this slide. When I did the work at CAG Consultants, we partnered on this work with Nordic Heat, who are, excuse me, sort of a group of municipalities in Scandinavia who have got together to offer their experience in district heating. Amongst other things, they have various training courses and some courses at Stowe College in England. And we also worked with Robin Wiltshire, who's an independent consultant, and he's chairing the IEA District Heating Working Group. We did the work for the UK government, so that's the Department for Business, Energy and Industrial Strategy. I think, like as I understand for Ireland, they are looking at what specific regulations they need to put in place for district heating. At the moment, there's really nothing specific to district heating. It's really just relying on general anti-competitive legislation. So they wanted to look internationally at what regulations were in place, what the lessons could be learned for the UK to inform their policy development. So I've given you a link to our work here, and also just to note that they have published a sort of policy consultation document on the back of that as well, if you're interested. What we did for BEIS was to do initially a sort of international rapid literature review, so looked at all the international literature on district heating, just to try and understand what the regulations were, what our choices and options were. The next stage of the work was to choose 5 case study markets and to kind of deep dive into them and interview people through semi-structured interviews, and we also did a regulatory document review. The regulatory document review, we looked at 100 laws and regulations. There's quite a lot out there, so that's there for you to plough through if you're so inclined. When we were talking to people, what we tried to do was in each market that we chose, we tried to speak to a developer, a regulator, and a customer. We did find it difficult to get representative customers in all the countries that we looked at, but I think we did get a developer and a regulator in every one of the 5 countries that we looked at. So here's our shortlisted countries. So that's the benefit of webinars, is that I can put a bit more detail on the slides. So we chose these companies based on, these countries based on some work that the IEA had done on categorizing countries into the status of their market. So we've got a whole suite of what's called refurbishing countries, which is basically Eastern Europe, where they've got extensive market penetration of district heat, but the systems are pretty inefficient, and there's maybe a limited amount that we could learn from those systems, and their main kind of focus for regulations is refurbishing. And then there's consolidation. So consolidating countries would be the kind of main Western European countries which have a high penetration of district heating, including Denmark, Sweden, Finland, Austria. We chose one of those, Finland, because we felt that Denmark and Sweden were pretty well covered in other literature, and we maybe couldn't learn a lot more from them. Finland was an interesting case for comparison with the UK, because it's quite a sort of generally market-based energy market, and and they had a reasonable sort of market share as well, but not as high as some of the other countries. Then there was expanding countries, so that's mainly Asia, Italy and Germany. So we chose one out of those. And then the last classification is emerging markets. So that's where there's really pretty low market share, but they're looking to sort of break into the market. I'm not actually quite sure where Ireland fits in that. Maybe emerging, I would imagine. So what we wanted to do was choose countries where the lessons were directly relevant. So the focus mainly, with the exception of Finland, is on markets where there's a reasonably low market share, but the focus is on expanding that, because that's what we want to do in the UK. So those are the markets that we wanted to study in detail. And across those 5 markets, we also looked to get a mixture of regulatory models. So that's, if I just go through this very quickly. So in British Columbia, there's an independent regulator, and it's very like Ofgem. It does all the same things that Ofgem does in the UK, or GB, sorry. But it only regulates private schemes. There are municipal schemes as well, which are free to operate out with that regulation. In Norway, they have a sort of light touch regulatory regime where essentially the government licenses schemes, does a bit of sort of price checking to make sure that prices are still within the mandated cap, and they kind of also do planning conditions and things like that as well. So that would look more like in the UK if BEIS, the UK government, took on regulation rather than Ofgem. The Netherlands are very, very like the UK in many aspects. A lot of the same challenges. Also, the kind of benchmark fuel in the Netherlands is gas, which is similar to the UK. Germany, no regulation whatsoever. Reasonably high market share, 15%. They do have a heat law, but there is no specific regulator or what we would sort of classify as specific district heating regulations. And then, as I said, Finland, again, like Germany, no regulation. Again, an energy efficiency law, but no kind of specific economic or consumer regulations. Again, if you look at the makeup of each of the industries, that's also really interesting. So for me, I'm a sort of electricity expert mainly. So it's quite interesting to look at a market where there's quite a lot of public sector involvement still in most, if not all, of the countries that we looked at. So as I said, in British Columbia, there is regulation of private schemes, but as a direct result of that, there's very few private schemes, and most of the schemes are developed by municipalities. In Norway, it's pretty mixed. They sort of started off as municipally owned schemes, but some of them have been sold off. In the Netherlands, as I say, it's quite like the UK, but there's quite a high percentage of the market is unregulated communal schemes, and there's only really 13 large-scale networks with mixed private and public ownership, which fall under the regulation of their regulator called ACM. Germany, very mixed bag, but strong presence of, I think it's a particular German thing called Stadtwerk. They are sort of municipally owned companies, but they don't necessarily operate out of their municipal areas. So it's sort of like Vattenfall coming to the UK and becoming an energy supplier. And then Finland, overwhelmingly municipally owned, 90% market share in the cities, 50% overall. And then I think one thing that sort of struck us as we were working through the circumstances in each of these countries is that what you would define as a customer in other countries isn't what we would define as a customer in Great Britain. So, as I'm sure you're all familiar with, mostly the customer in district heating terms is the building owner. But when you're regulating for customers in GB energy market, you would be regulating for individual consumers, in your flat. And I think that works quite well, that sort of model for district heating where there are, where it's quite common to have a building heating for a whole building, which we just really don't have that much of in the UK. But it is very, very common in the other countries that we looked at. And in that respect, none of the countries are really comparable to the UK. So in British Columbia, it's very common to have what they call strata, which are kind of tenant-owned organisations which look after the heating in apartment buildings. Norway's, the main customers are commercial building owners. Netherlands, the same. Germany, the same. Finland, industry ownership and tenants associations. So the feedback we were getting from consumers needs to be seen in that sort of context. It's not sort of like in the UK. You would have your own individual boiler in your own flat, and you would be talking to your energy supplier directly. Pricing. I've got another slide which goes into a bit more detail on pricing, but fair to say there's a good mixture of models that we had to study. So some of the markets didn't have any price regulation at all, and then Norway and Netherlands both cap their district heating prices. Norway electricity heating price, Netherlands at gas, and in British Columbia they just sort of have their own policies within each municipality. Vancouver would have a sort of pricing board where they'd agree pricing each year. Others will do it differently. We also looked at measures to promote investment in district heating and focus particularly on whether mandatory connection is needed to promote investment. I'll get onto that again later, but there was again a good mixture of models for us to look at, some with mandatory connection, some not. And then finally, fuel use, we looked at decarbonisation. I've listed the fuel kind of mix for each of those countries, but I think it more or less reflects the fuel mix for electricity in each of those countries as well. Norway's had a very strong push on using district heating as a result of some push on waste to energy schemes. Finland is very biofuel focused. Germany coal, Netherlands gas, British Columbia gas. We'll go on to the next slide. Just to kind of go through some themes of the work that we came across throughout the work. So, can district heating be unbundled? So, competitive sort of regulation of markets is predicated on separating out the competitive and the non-competitive bits, and the idea is that if it's competitive, it can regulate itself through price competition. If it's not competitive, it's the regulator. So first thing is, can you do that for district heating? I will tell you later. Then if there is competition, where does that pressure apply? Is it when the consumer is choosing a supplier, or is it when a building is choosing a supplier? Or is it when a municipality is choosing a district heating scheme? Can district heating offer choice in the same way as other markets? Kind of interactive question. Who is the customer? And can these questions be separated from the issue of who owns the district heating scheme? And do all these things change as the market gets bigger? Or is district heating a special case? So regulatory models, I think I've touched on some of these at the moment. We basically concluded that the UK government had already decided that they probably did want a specific regulatory regime, and we agreed with them that that would be beneficial. And I think there's two kind of driving factors towards that. One is that district heating does rely on customers not switching, so they do need some level of protection. An industry would benefit from standardised codes and practices. In the UK, there's been some work already by an organisation called CIBSE. There's also been work on protecting consumers at a voluntary level by the Heat Trust. So there's plenty of work that can be built on to make that more of a formal scheme. Other things probably worth mentioning. British Columbia is a really odd situation where, to me anyway, where they've kind of linked regulation to ownership. So they kind of assume that municipal schemes will act on behalf of their sort of constituents, and that the consumer pressure is assumed to be political pressure. So you wouldn't vote for that party next time round if the district heating scheme didn't work. And there was no sort of evidence of particular complaint schemes, anything like that. There was just a sort of assumption that political pressure would drive excellence in those schemes. It was difficult for us to argue against that, because that's one of the countries where we couldn't really speak to, we didn't find any consumers to speak to. Yeah, I think I've probably covered the rest. Yeah, the Norway system is very light touch, and it's kind of based on trust between industry and government. Or in all of the markets that we looked at, there is predominantly vertical integration, so generation, supply, distribution, transmission is all the same company. There has been some third-party sort of generation supplies, and there is a market in the Netherlands and Finland, I think, but that's the very small sort of percentages of the heat supplied, and it's just limited to those larger schemes. We did read there were some sort of there were some investigations into unbundling in Sweden and the Netherlands, both concluding that the costs of doing that, so the metering, the transactional costs, were just too much and didn't really make it worthwhile. There's also an argument that the closed loop system of district heating means that it's much more difficult to separate out those elements. And also worth noting that with the exception of Denmark, whatever the ownership model is, so municipal and private, all of the schemes are run for profit. Denmark does have a law that you need to strip profit out of district heating schemes, but they do allow profit in the supply chain. Consumer protection, I've probably covered most of this already. As I said, there's a different definition of what you would call consumers. This on the right here is an extract from a German, so there's laws on price transparency in Germany. So one of the customers that we spoke to gave us what the price transparency looked like for one of the Stadtwerke, and that was it. So obviously that's way too complex for you to actually know what your price is. So although the German system would maybe argue that there is laws on price transparency, without proper consumer protection, there is some bad practice. And there's also across the board, across a lot of the countries that looked at, issues with contract length, ability to kind of extract yourself from a contract, price transparency, and very little evidence of proper complaints processes across the board. And also, interestingly, this issue of what happens if a district heating provider goes bankrupt. It's a really, really, really hard issue to solve, and none of the countries that we looked at had solved that. It's kind of easy in electricity because all you're doing is taking on customers, but in district heating, if you're vertically integrated, you're taking on the whole system. And no one has really cracked that, although Netherlands and Sweden have both looked at it. And then I've just listed there the complaints procedures that different countries are using. Again, really only the sort of properly regulated ones have formal processes where somebody who's not self-organized could go and make a complaint. Just one more thing, that the recourse in the unregulated markets is basically the competition authority in that country. We did come across cases where tenants or commercial building owners have got together and made a complaint at that level, but obviously it's not something you can expect your average consumer to be doing. Prices, I've listed, it's very difficult to get prices on district heating, but we've used the IrDEA prices for most of these and pulled off some prices from the municipalities in British Columbia. They mainly broadly reflect electricity or gas prices in each country, largely because for some of those markets they're capped at those prices. There was a lot of emphasis on price transparency in quite a lot of the markets. Sweden has a system of a pricing dialogue, which it opens with its customers. It's voluntary, but reportedly has very high kind of approval ratings. Denmark, as sort of experienced and mature that market is, they're still really struggling to benchmark prices between different schemes. They publish them, they're all transparent, but making that meaningful and benchmarking them against each other is really difficult because there's such huge diversity across all of the schemes. And then mandatory connection. So most of the markets that we looked at have used mandatory connection to build district heating schemes at scale. But those are falling out of fashion. So both Finland and Denmark have very, very recently repealed those powers, and Norway's considering doing the same. At the same time, Netherlands is the only one that's considering expanding mandatory connection powers to residential buildings, I think. Where they do have powers, we found surprisingly that they're not often used in some countries, so in Germany and Norway. There's a preference to use negotiation or municipal policies, and also a big driver, which I noted an earlier speaker had mentioned, is building standards. So that's considered to be an increasingly important driver. So it's essentially creating the situation where in the appropriate circumstances, in an urban setting, where other technologies wouldn't be appropriate, that you would need to have district heating to meet that building standard. And also the ban on connecting new buildings to the gas network, which is in place in the Netherlands and in the UK, is going to be increasingly important. I think this is my last slide. So a couple more. Decarbonisation. This is the one area of our brief where we found that it's very much a work in progress. It's not great progress has been made in the countries that we studied. Norway had, as I mentioned, had a push for waste to energy, but largely the fuel mix in district heating reflects the fuel mix in the energy sector. There's very high levels of gas and coal in the Netherlands and the German systems respectively. Norway, they can set decarbonisation targets for schemes when they issue a licence, and the government told us there that they just do that on a case-by-case basis. Not quite sure how that would go down in other markets, but it seemed to be fine there. And then the Netherlands was the only one where we found a sort of market-based subsidy, which was equivalent to what I would say would be the ROC, renewable certificate scheme in the UK for heat, which was really interesting. And as I said, the ban on connection to gas networks, which is due to come in the UK soon and in the Netherlands, will be really important in decarbonising the networks in those countries, I think. Then I've just put at the end a couple of contacts for my sort of collaborators, colleagues on this. And then, as I say, I've moved companies since I did this work, so it's been about a year since I thought about district heating. So my contacts are there if anyone wants to speak to me.
Great, Helen. Thank you very much for a very extensive overview of the regulation space. It struck me there looking at some of the numbers around the opportunity there is for Ireland around, I would say, a very low carbon fuel mix in terms of district heating in Ireland. So it's encouraging to see the opportunity there for us. Next up, I'm going to introduce Giles Newton, from Head of Business Development UK and Ireland for district heat for SSE. Giles has worked in the district heating and cooling sector for the past decade. He's filled operational and project management roles, as well as business development and commercial positions at SSE. He's had a unique insight into the challenges and opportunities presented by district heating. Projects of note that Giles has been involved in include a 16,000 home development in Greenwich, Heathrow Airport, high steam network in Slough supplying Mars confectionery, an open loop aquifer-based heat pump network in Wandsworth, and the introduction of an innovative new metering and billing strategy across a portfolio of 10,000 homes. So quite a bit of experience there, and looking forward to hear what Giles has to say about UK experience on standards. Over to you, Giles.
Great, thanks very much. I think I'm under a little bit of time pressure, so I'll see.
Don't feel any panic. No.
I'll see how quickly I can get through and call out some of the key points, which are my kind of key learnings from my experience in the sector. So hopefully there we should be in presentation mode. Is
All
that all
good.
right, Brian?
Absolutely.
Yeah, so thanks for inviting me to talk. I've been given the topic of covering kind of my key lessons of operating district heat networks over the last 10 or so years, and how these lessons can be applied to the Irish market. I mean, I'd love to speak about the future potential of district heat. So hopefully this doesn't seem too negative. I think there are a lot of lessons and a lot of painful experiences we've had in the UK, but that certainly shouldn't detract from the great potential of district heat. And I think the most important thing is these lessons are all avoidable. But strikingly, hearing Fintan and Paul speak earlier, it's clear that some of these issues with district heat are already happening in the Irish market. So let's act quickly and hope that we don't make those same mistakes. So again, I mean, I'll rattle through slightly quicker than this, but I just wanted to cover a few of the policy barriers, policy drivers and barriers to DH deployment in the UK. We'll then move on to some operational lessons before just summarising with some recommendations for district heat policy in Ireland. SSE have a big business in Ireland. We'll move through that, but for those not aware, we've obviously been developing the Arklow Bank offshore wind site recently. We're actually the largest renewable generator on the island of Ireland. We contribute around 650 million euros to the Irish economy on a yearly basis. But SSE in general is really trying to lead this charge to a net zero world across the UK and Ireland, and we've committed to spending about £4 million per day on low carbon technology over the next 5 years. So some pretty big ambitions. I'll start with where I feel the Irish market wants to get to. This has been covered a little bit, and it's an admirable ambition, but there's a lot of discussion around municipal-owned pipe networks with an open access to regulated retail suppliers and low-carbon heat sources feeding into those pipe networks. It kind of mirrors the electricity network system, and you know, we totally support that approach. How you get there is going to be the challenging section, and I think it's going to require some good private sector involvement on that pathway. So hopefully some of that is covered in these slides. This is one of our networks in London. It's quite an interesting one down in Woolwich. It was actually installed 10 years ago. So it shows the kind of breadth of experience we've had. Now, I'm going to bring my pointer up. So these are the current UK, and I think what we'll see as I go through current to future, the balance is definitely shifting towards drivers away from barriers. But just to call out some of the key ones, planning has been an incredibly useful way of mandating district heating in new buildings. Emissions targets versus Part L have been ambitious in the Greater London Authority. Now most buildings are required to meet 50% carbon emissions versus Part L. So that's a huge driver for district heat, and clearly we're seeing a similar approach in Ireland at the moment. SAP is the way we assess those targets, those emission savings, and that is heavily linked now with a new version of SAP that has been released that links those emissions to that much lower carbon intensity of grid electricity. So now there's a big focus on heat pumps as we move away from gas. So some really good news there. There has been a lot of grant funding support, not as much potentially as the Committee on Climate Change is saying there needs to be, but with HNIP, the Heat Networks Investment Project, there has been some fantastic schemes being developed. We're in the middle of that process. It provides grant and low interest loan money to district networks, so not necessarily communal, and that has really increased the rate of district heat deployment in the UK. So that's been fantastic. then a current one, which is a real statement of intent, which is the Public Sector Heat Decarbonisation Fund. This is £1 billion worth of grant money available to public sector entities to install low carbon heating technologies, and has caused me some pretty late evenings recently in supporting some schemes through that application process. I'm not going to go into too much on the Heat Trust because I know Joanna's next, but I think the Heat Trust has been a huge success in supporting customers through that voluntary code of practice. Something that we're looking into in the Irish market is a technical code of practice. This provides a minimum standard for installation and design qualities, and as I will harp on quite a lot about later, one of the key issues has been historic and legacy network performance in the UK. It really has caused some bad atmosphere with residents and customers on district heat, and it's been because design standards just haven't been good enough, or the lessons that we just haven't learned them fast enough. Again, a lot of political will, and I put this down because I think it has been a huge help. I work with a lot of clients at the moment who are setting net zero targets and climate emergency targets, which have definitely supported their ambitions to deploy district heating. So some of the barriers, obviously gas, we know it's the same in Ireland. It is cheap, and it therefore makes a challenge as we base, people expect heat to be cheaper than that of gas, which is certainly possible with district heat. It definitely is possible. But that cost of gas doesn't take into account the social impact of all those carbon emissions associated with burning gas. Again, there is a bit of a barrier around higher capex versus traditional utilities. There's a business model around this in the UK as well, where electricity connections, gas connections, quite often that utility operator can offer capital contributions to install those networks, whereas obviously with heat, we're in a different scenario. And I think those are the key points out there. But as we move into the future, it is getting more positive. The balance is definitely shifting. One thing that I haven't seen mentioned in this talk so far, which I think is such a huge point, and I'll pull out a fact from the Committee on Climate Change, is this flexibility angle. So I am now seeing a lot of new networks that are having to look at electrically driven heat, and they are therefore going to their local DNO, the electricity board, the electricity network, to apply for connection, and they are having huge connection costs handed back to them, some which are making these housing developments non-viable. When we move to district heat networks, we've got access to cheap thermal storage, these big vessels of hot water which can be preheated. We have heat pumps offer this kind of fast dispatchable flexibility. The Committee on Climate Change has stated in a recent report that this could be worth up to £16 billion per year to the UK economy in allowing more renewables onto the grid. I mean, and I haven't misquoted that, £16 billion per year. So please don't forget this flexibility angle. It's really important. And to make use of flexibility, we have to design in proper thermal storage and system control from an early stage. We've spoken a little bit about zoning, definitely in some of the other talks, but we have another grant funding pot, which is fantastic, called the Green Heat Networks Fund. I've been involved in steering some of the decisions made around this one. That is supporting waste heat generators, so energy from waste plants, data centers, to make that waste heat available. So hopefully that's going to be a fantastic scheme and will provide more access to waste heat into our heat networks. Some fairly niche ones here, but in the UK, and this isn't again an issue in Ireland, which is great to see, but we have no real carbon tax beyond ETS. I think the statement in the UK at the moment is, yes, we'll adopt an ETS style system when we leave the European Union, but we don't have any real plans for carbon tax. Let's hope that changes. Conscious of time, so these slides will be sent out, and please get in touch if you have any more questions. The balance is shifting, but there's a long way to go. We're here down in 2020, and if you look at the value of heat output that needs to come from district heat networks to meet our 20% target by 2050, I mean, we are so far off, which is in my view a huge opportunity. I'm going to just move through straight into some of the technical lessons, because I think that's really where I can hopefully offer some value to anyone who's thinking of developing district heat in the near future. These were my five lessons. I'll cover it a bit more, but nearly all system performance issues are caused by poor design at an early stage. Paul said something very similar. Now, I say nearly all. I'm sure people can find, if water quality, or there are things that will cause poor network performance other than design. But I really mean it when I say that this section is so important. It causes all sorts of issues, and is principally decided at concept stage. Commissioning, again, in the UK, it took us a long time to understand how to properly commission a system. Fintan said exactly this point, so I'll expand on it. Metering infrastructure, hopefully something you're very good at in the Irish market. I think the key point to take away here is that you can see a lot with good metering infrastructure, and metering infrastructure is really cheap and easy to deploy. So it's a no-brainer to include in any network design. I'm not going to cover 4 because Joanna is after me, and again, she'll cover a lot of this with the heat trust. I think if anything, it's just about standardized contracts, and making sure that customers have access to all the information they need about connecting to this district heat network before they buy or lease a property. So it's just that communication element. And then something which we still suffer from in the UK, which is traditional procurement processes, which we can't seem to get rid of. But I've got some diagrams on that in a second. So if anyone's developing a district heat network, you can go down this list and make sure you're asking whoever's designing the network to make sure they're covering off these points. But we still see massive oversizing in district heat design in the UK. We looked at a scheme the other day, and we were this is in 2020, and we were able to save 30% capex due to oversizing of equipment. And I'm sad to say that they came back and said, oh, well, we designed it on the CIBSE code of practice, which shows that these technical code of practices do have to be updated as we go through and learn more in a sector. But a lot of sizing will be based on Swedish or Danish diversity models. We have found that actually we now use our own data to develop our own diversity models. Diversity, for people who don't understand, is basically when you're sizing equipment, you add up the peak demand for each apartment, each building, and then you apply a diversity factor that says that not all of those connections are going to be using their peak heating requirement at any one time. And people are still too conservative with those estimates. And the problem when you oversize equipment is you end up with a whole range of issues, like short cycling of equipment, high return temperatures, so your heat pumps don't run effectively. End up with pumps not meeting their minimum flow requirements. I worked on a network where that minimum flow requirement was causing such loud banging in pipe networks that they had to move around 300 residents out of an apartment block and put them into a hotel until it could be resolved. So please do not oversize equipment. And if we got procurement practices right and bring the operators in early, these issues can often be kicked out at such an early stage. Thermal storage is often an afterthought. You know, there's a lot of potential for thermal storage, as I spoke about, with that flexibility angle. We put in hydraulic separation and heat exchangers almost like they're going out of fashion. It's unnecessary. You can get around a lot of these issues. And people say to me, oh, we do it because of water quality. Well, that suggests that you're just pushing the problem down the line and assuming that water quality is bad in a secondary connection. Bypass valves, we see them put in everywhere. Please avoid them. Please avoid low loss headers. So any questions on those, please get in touch. Conscious of time, this is an obvious one, but there is so much that you can see from data. And if I said to you that collecting 15-minute, collecting a data read from a meter every 15 minutes, we collect 4 different points of data: consumption, flow rate, flow temperature, and return temperature every 15 minutes from every meter, and that costs us around €7 per meter per year. It's really such a low cost, yet you can see so much from it, which we can see down to individual apartments. We can see where if a valve is failing, if a strain is blocked, just by those 4 data points. So definitely something to consider. This is probably my final point then, which is this has been a very traditional procurement route in the UK, where a system has been developed by a developer or whoever might be the ultimate owner. We then start bringing in an M&E consultant who wants to save cost. They're trying to drive a low margin business in installing this equipment. Sorry, the M&E contractor here, the M&E consultant is often designing this, unfortunately, with a lack of operational data, which should really be shared in the market. I mean, we obviously have the benefit of it, but we don't share it willingly enough. M&E contractors trying to squeeze those margins, and then suddenly we get this situation where the whole network is just handed over to an ESCO who takes on all of that long-term risk. It isn't the best model, because I can remember one of my first ever networks. We adopted this network, and we were only brought in the day of practical completion. So the M&E contractor wanted to get off site, and you start having this big barrier to ESCOs adopting, because if we're about to take on the risk for 25 years, we want to make sure the whole thing's working correctly, which comes down to that commissioning and not just commissioning a system as a whole. And unfortunately, I don't think I've got time to discuss that. But this would be a plan for the future, and just bringing that ESCO in at an earlier stage, because they will take risk on the design. They're not saying they're going to do the design, but they will take diversity risk, sizing risk, and that's a really important point. Competitive dialogue is our favoured. It allows projects to come to market faster, because you can sort of solve the issue as you're developing, as you're going through the procurement process. So recommendations for the future, that's great to see some of these already coming into play, like strong non-ETS carbon pricing. We definitely welcome that. Heat network zoning, Scotland has a great example of how this might be implemented. We're very in favour of that, and it allows those networks to be passed to municipal ownership, potentially after they've been developed by a private sector entity. The big one that Finton and where I'll finish is this. We have to, in Ireland, reassess this treatment of Article 5 of the Renewable Energy Directive and allow deep calculations to be applied more appropriately. This is not encouraging use of waste heat in district heat networks. We need this to not be a barrier. We need this to be opened up and more easy to use. So there you go. Thanks very much.
Giles, thank you so much. Some very rich insights there, and plenty for us to take on board in Ireland when we're considering the development of our market. Lessons learned, very valuable lessons learned there, I think, and I'm sure there'll be plenty of questions later on that. Thanks again, Giles. Now, our concluding presentation for this session comes from Joanna Reid, who's Policy and Operations Advisor, Heat Trust UK. Joanna leads on the monitoring and auditing of Heat Trust members' suppliers. She also has particular focus on standards relating to vulnerable customers. Heat Trust is a voluntary customer protection scheme for heat networks in the UK, supporting customers, suppliers and policymakers in the run-up to regulation. And Joanna is going to talk to us about customer protection. Joanna, over to you.
Great, thank you. I'm just going to try and share my slides. Can you see that?
Not in full screen yet.
Okay, let's try again. How about that?
That's good, Joanna, perfect, thank you.
Okay, brilliant. So thank you for the introduction. I think I've been really well set up by the previous two speakers, so thank you to you as well. I'm going to talk to you today about why it's got to work for customers. So how to ensure that satisfied customers really are the fuel for growth of the heat network market. Just go on to the next slide. Okay, so this has been mostly covered by the others, so I'll just quickly whistle through. In the UK, heating and hot water account for about 40% of our energy use and 20% of our greenhouse gas emissions. We need to decarbonise every sector as soon as possible. Heating is no exception. And we've actually legislated in the UK that we've got to reach net zero by 2050, which scarily is now only about 30 years away. And the Committee on Climate Change, the UK government's independent scientific advisory body, have modelled that heat networks could provide up to 18% of heat demand by 2050. And this includes about 5 million homes. This is up from only about 500,000 homes now. And an even higher proportion is set to come from non-domestic sector. So this is a lot of customers that we're talking about here. I know other speakers have touched on these, so just to acknowledge there are other barriers to expansion of the heat network market, such as demand assurance, the counterfactual in gas being so cheap, and in the UK about 85% of homes are connected to the gas grid. But hopefully by the end of this presentation you'll agree that customer acceptance is also a really big one. So I want to do a quick imagine exercise with you. Feel free to hum along John Lennon because you're not going to be disturbing the person next to you. But imagine you are a mother of three small children and the heating and hot water has been out for a week and it's hard enough to get them to wash their hands or take a bath at the best of times, even when let alone when the water is cold. Or you're an elderly couple who can't really read their bill anymore and you can't do this newfangled online accounting thing. Or you're a chef in a restaurant that's been closed by COVID for the last however many months. And so you're starting to struggle to pay your bills, your heat bill included. Or you're a first-time homeowner just moving into your brand new shiny house, or new to you, but the previous occupier didn't notify that heat supplier when they left, so you're getting charged for their usage from over 2 years ago, which you didn't factor into your budget when moving house. Now, don't get me wrong, this is not the entire picture of heat networks in the UK, but these are some of the scenarios that we see. And these customers are not going to be ambassadors for heat networks. They're not going to go and tell their friends, hey, come and live on this great new system that has the potential to be really great for customers. So that's the problem. What do you do about it? Well, in the UK, the answer 5 years ago was to launch Heat Trust, which is a collaboration between industry, largely the Association for Decentralised Energy, and government, to set up a minimum standard scheme for customer protection that suppliers would voluntarily sign up to. This is also known as self-regulation. And we've managed to expand really quite rapidly over the last 5 years. starting with just over 30 sites. We're now over 90. We started with only about three suppliers that we call registered participants. We're now coming up to 20, and we're now covering about 53,000 customers at the last count. So conscious of time, but I just wanted to give you a quick flavour of some of the standards that we do set. A key one, I think Giles mentioned, is setting out the key terms of service to your customers. This can be either through a heat supply agreement or through a customer charter if your contract includes, for example, rent or other utilities, and it's difficult to separate them out. We set various standards on customer communication, from things basics that it's got to be easily intelligible English. And we have standards for vulnerable customers that at Heat Trust we actually split into two. One being for customers who require additional communication support, for example, that elderly couple who can't read their bill, to those who are more vulnerable to cold, for example, chronically ill or potentially the elderly, with different services tailored to these two different groups. For example, different communication methods, larger print bills, and schemes for when engineers go out and visit site, and others such as no disconnection during the heating season for vulnerable customers if it's a debt issue. We set various standards on billing and payment, for example, breaking down what the heat charge is made up of, displaying consumption, a set number of days between reminder letters for chasing bills, that kind of thing. We have standards for response times to faults and interruptions, so telling the customer what's going on, what the anticipated timescales are going to be, and resolve time, so minimum time periods within which an outage in supply has to be fixed by, and compensation payments for if those are not met. And finally, we require our suppliers to have a robust complaints procedure. And this also includes, through registering with Heat Trust, access to an independent dispute resolution service through the Energy Ombudsman. So a customer can take a complaint that's not been resolved within 8 weeks to this service. Both parties get to present their evidence, their case, and someone independent will arbitrate. These are largely based on Ofgem standards. This is the regulator for the gas and electricity market in the UK. And all of our scheme rules are actually available on our website if you want to go and have a look in some more detail. So we've set up our customer standards scheme. Next step is to check that suppliers are actually doing what they said they were going to do. So this is where I come in. I joined Heat Trust June last year to mainly look at monitoring data and audits. So we collect various metrics every 6 months. These go into our annual report, so please do again head to our website if you want to find out what the most common cause of complaint is in the UK heat network market. Spoiler, it's billing and charges, or the most common cause of unplanned interruption at a site-wide scale. Again, spoiler, it's usually the pump and pressurization unit. But we also use this data to prioritize sites for audit. Audits are conducted by independent auditors that we bring in, and they take a look at the supplier's processes to check if they are compliant, and it goes through an iterative stage. So it's less of a finger pointing exercise and more of a let's identify some areas to be improved and work together to bring everything up to the pass mark, with the overall aim of improving a customer's experience. But this has also raised some heat network-wide issues that can't be solved by single suppliers alone, such as pre-contractual transparency. How do you ensure that that the terms of service get to customers before they move into a heat network? This requires collaboration and understanding of, say, developers or estate agents, and so things to be tackled more as an industry-wide issue. And it's also our key route to customer assurance. So we're checking that our suppliers are doing what they say they're doing, but how do we know that the scheme itself is actually producing any kind of customer benefit? Through our annual reports, we've showed that last year there were actually 63 fewer complaints than the year before, and actually a lower complaint to customer ratio, than in the regulated sector. These complaints that go to the independent arbitrator, the ombudsman, are largely upheld. So the ombudsman agrees with the customer that a mistake was made, or something went wrong, and more could be done to remedy the situation. Compensation payments are also being made to customers. Last year, this was to the tune of about £25,000 for unplanned outages that lasted too long. And we also have quite a robust application process. So we check for evidence that processes are in place to meet the scheme. The audit process then goes in and checks that those processes are compliant. But there was also an independent, so this was all from our annual report. You can check those facts online. But the Government Department for Business, Energy and Industrial Strategy conducted an independent consumer survey in 2017. The link is at the bottom of the slide there, that showed that customers on heat networks that were registered with Heat Trust are much more likely to receive information on their system that then puts them in control. For example, information on billing or the type of system that they have. So we've set up our customer protection scheme, we're checking that it's all working. What's the next step? Well, in the UK, still about 89% of existing heat network customers are yet to be protected. All of the major ESCOs operating on heat networks in the UK are now registered with, have registered at least one site with Heat Trust. But the vast, 89% of customers are still not yet on a site registered with us. And this is largely local authorities or housing associations. So the next step for us is regulation, is statutory regulation. This is being developed both in Scotland and for Great Britain as a whole. And Heat Trust, we see ourselves as a stepping stone to that, in getting suppliers ready for regulation, as we're providing the template for this regulation to be developed. And we're having lots of conversations with Ofgem, who is tipped to be the regulator, providing our expertise, our data. We've been doing this for the last 5 years. And I'm sure I'm running out of time by now, but I did just want to highlight one other point that I feel could be improved, is a lack of diversity in the energy sector. Just as a whole, this is not specific to heat networks. So in the UK, there is a women's networking for women in heat networks called the District Heating Divas. They do have a website, so do go check it out. We have monthly catch-ups, sometimes with a specific topic, sometimes just to chat. We have an annual conference. We also have a mentoring scheme to support and retain young talent in the industry. And there's various kind of unconscious bias training that can be undertaken for things like racial diversity in the sector. So where do we want to get to with all of this? Well, if we take it back to those scenarios at the beginning, what we want to see is the mother of young children with the heating or water out. It's either fixed within 24 hours or they're kept up to speed at every stage of the process, and they're provided with an alternative source of heating if they're classed as vulnerable. Elderly couple who can't read their bill are provided with a large print bill or an audio bill, or they can nominate a trusted friend or family member to deal with their billing for them. Or the chef who's struggling to pay their bills is supported through that. They are set up on a repayment plan that takes into account their ability to pay, and they're forwarded to independent financial advice such as citizens advice, money advice, trust, step change, so that they can get additional support. And we actually have a back billing rule that a supplier can't charge historic consumption for longer than 12 months in the past. So the idea that we're getting to is customers trust their supplier, they have understanding, transparency of their system, and this leads to acceptance. So that's where we want to get to. How do we get there? That's up to us. So sorry for the cheesy ending. Those are contact details and our website. There's lots of resources on there, or please do get in touch if you've got any questions. I think we're going to go to a short question and answer session. Thank you.
Thanks, Joanna. Very interesting in terms of customers critical to the success of any industry, I think. So again, lots of lessons to be learned from the experience in the UK so far. Sorry, just to turn my video on again, excuse me. So yes, we're going to jump into a few questions here. Just bear with me 1 second, just go back to the beginning. Yeah, just first question here for Xavier, who's on the line there, is just from Connor. Are the changes, or risk of changes to sources of waste heat factored into model scenarios? For example, if there's a decline in waste heat from power generation, particularly seasonally?
That's a very good question. I would say not explicitly, but I suppose one thing I would mention is that, generally speaking, so we'll look at the overall envelope in terms of waste heat available, and our projections for the RES DH++ scenario, so the 35% penetration, only taps in 33% of what's been identified as the overall potential for surplus heat. And obviously the big advantage with surplus heat is that it's cheap, and within that cohort you have high growth areas such as data centers, for example, that can be in a position to compensate for a reduction in let's say surplus heat from power gen, and I think in that context we're looking at integrated solutions and district heating, taking heat from different sources, and I think the role of thermal storage can also be important in leveling those peaks and enabling a power gen system to be in sync, let's say, with the district heating requirement to a degree. So I think there's plenty of scope within what's available, and while that needs to be looked at on the case, project by project basis, I think generally speaking, it's I wouldn't consider it a massive issue.
Yeah, I think it's fair to say that the changing dynamic of operational regimes of generation plant is something that's changing year to year. So it's a hard thing to forecast accurately, but I think in fairness, a good effort to be made at that. Thank you, Xavier. And Helen, if you're still there, a question from Donna. While mandatory connections are falling out of favor in very mature markets, do you think there's a need that they need to play a role in emerging and new markets?
So as I said, all of the markets that have got significant scale have used mandatory connection, and it's just a question of whether building standards are a sufficient substitute incentive to achieve what mandatory connection did. And I think my understanding is that, I haven't read the full BEIS recommendations, but I think they want to allow that to be a flexible choice for individual local authorities to choose whether they zone or not, or whether they use building standards. There was no evidence really that, well, there's overwhelming evidence that mandatory connection works, but there's a question whether it's needed.
Yeah. Okay, thank you very much, Helen. And a question for Giles from Neil. Does SSE have any data they'd be willing to share in terms of domestic hot water diversity? And I think it might be particularly in reference to the differences between normal residential homes and maybe student accommodation situations, for instance, or anything that you could share with us, Giles?
Yeah, definitely. We do have lots of data. We do have plenty of data on residential DHW, and we have a few student accommodation blocks. So there is data available. I think just the UK in general has been very bad at sharing data. The metering and billing regs only requires you to submit bulk supply meters, so not the most useful, a little bit useful, but not the most useful. And I can't remember, Joanna, whether the Heat Trust collects this data and whether it's allowed to be made public on a statistical basis. I don't think that's true. So we generally just haven't had a forum to share data. So it needs to be changed, I think.
Okay, thank you, Giles. And finally, for Joanna there, just a question relating to the Heat Trust started as a voluntary scheme. Are there plans to make it compulsory?
Not in its current form. I guess the statutory regulation is going to be largely based, well, the customer protection element of the statutory regulation is going to be largely based, we hope, on Heat Trust rules. So that will then be mandatory. They are looking at certain thresholds, I think, for which heat networks would be required to meet certain thresholds. But I guess that would then be mandatory for all. And just to respond to Giles' point, we don't collect data on kind of consumption. All the data we collect on, like complaints numbers, outages, is published in our annual report.
Very good. And actually, just one more question for you, Joanna, as you're there. Yep. Around the Heat Trust calculator has been a great tool. Given that the boiler counterfactual is becoming less common in new developments due to SAP, will Heat Trust be producing a heat pump counterfactual calculator?
Good question. So yes, one of the key things when we started was we provided called a heat cost calculator, where heat network customers are able to enter into our online tool either their consumption or their bill, and should be able to compare roughly what they would pay for a similar property if they had a gas boiler. As the person who asked the question points out, certainly as we move forward, gas is going to become less and less counterfactual, and electricity and heat pumps are going forward. So we've actually done some work looking at the formulas for comparing against electric, I think mainly electric, either storage or panel heaters. That work is on our website. If you go into the consultations area, we found not enough publicly available data yet to develop one for heat pumps specifically, although we hope as the heat pump industry expands, that data will become either available or more publicly available. If so, that's something we could look to pursue. So yes, potentially at some point in the future. If you can point us towards any reliable, publicly available heat pump data, please do.
Yeah, that was from Daniel Barnes. I'm sure Daniel can forward on any further follow-up to that to Donna directly. It's interesting you say that, because certainly in Ireland now we're in the new build sector. Our building regulations are driving heat pump deployment in new homes out towards 70% in 2020, early 2020. So very significant shift in usage in our built environment already. So it's an important point. Look, that's the conclusion of the Q&A for this session. It's the conclusion of the session. Just to say thank you very much to Helen, to Giles, to Joanna, and to Xavier for keeping us bang on time. I think we've landed bang on 1:10 and a pleasure to hear your contributions. And I'll now happily hand over to Donna to make some closing remarks. Thank you all.
That's great, Brian. Great job moderating. I knew you'd get us back on time in the end. So yeah, great closing session. There are lots of interaction from the audience, which is great to see, and lots of great questions coming in. Just to remark and to highlight, to come in on Joanna's point around diversity, and I suppose Helen's remark as well around her being more Andrews than women in her initial role. We were very lucky, I suppose, to have great women involved in the conference over the last 2 days, and we did manage a 60-40 male-female split over the conference, which was great. So big thanks to the ladies for joining us over the last couple of days. And also the gents, of course, and I know a lot of the IrDEA members are very supportive of gender diversity, and in IrDEA we do try our best, and so the guys have been great support for that. So a big thank you as well to our IrDEA members in general. Over the last couple of years, it's been great to have the support of the members, even though I suppose district heating is a new market for Ireland. It is great to have such an interest and such kind of really good members and active members involved in IrDEA. So big thank you again to all of the speakers on day 1 and day 2. Big thanks to all the attendees and all your great questions coming in. It's been a very interactive couple of days. Our sponsors again, Vattenfall and Dublin Waste Energy, thank you very much for your sponsorship and making it possible for us to have an online event this year. Obviously ticket sales, tricky to do with online events. But hopefully we'll see you all in person next year, and you'll be able to attend our conference in Dublin. And big thank you to the conference organisers. So Codima have been in the background organising all this for us, and Suzanne Fitzpatrick there has been the puppet master in the background. So thank you very much to Suzanne for keeping us all on track and keeping everything together. And just one final reminder that everything will be available on the IrDEA website in the next couple of days, the recordings of both the sessions. So please do pass them on to anyone who wasn't able to make it. All the presentations will also be available. And just a reminder of the training that IrDEA will be hosting early next year. The details of that training are available, and there you can see the details on the slide there now, and it is available open for booking now on the website link there, which again we'll put a link to on the IrDEA website, and again we'll circulate these slides afterwards. So thank you very much all for attending, and we hope to see you again next year.